And then I was a little curious about finding out the reasons why it is like that. Okay.
Okay.
I did get an answer about it in some place, and I want to test it along with you guys. So maybe we will test that about that /32 for the data path. So do that, but before that, let us make these systems communicate.
Okay, Kalyan, when we talk about the data plane, am I audible?
Yeah, it's breaking a little bit again.
Oh, so actually what I was asking means when we talk about the data plane in the MPLS, so data plane is that when we enable the MPLS IP on the interfaces and LD related to LDP, label distribution protocol.
Yes.
That is called data plane. And LDP is prepend the label, which is called transport.
Yeah.
Transport.
In voice is breaking.
Oh, so Kalyan, I am saying that LDP is means we can say push the label. That is called transport label. Am I audible?
Deepak, you are audible, but looks like issue at Kalyan end.
Oh, that is fine. I thought again I'm facing the network issue.
I'm able to see the screen here.
Means put
I
the
don't know
tag.
why I'm not able to see the desktop of yours.
Yeah, but my desktop is shared.
Why here?
Guys, anyone of you?
No, I'm able to see your desktop on your thing, the one which you shared. I'm not able to open it. I'm not able to open the console.
No, Kulyan, actually, I was trying to ask about your GNS3 config files for our reference. MPLS lab config files.
Oh, I forgot, man. Yeah. I'm sorry. I'll send you.
Yeah, thanks, Kalyan. From GNS3, we can export the config file of all our routers, right? Or we
Yes,
log into
as a matter of fact, it's all going to stay in a folder. In the project folder, or configs subfolder will be there. It will be in that.
Okay.
All that I have to do is share that subfolder. That's it. Okay, I'm able to see it. Now, okay, I don't know why I was not able. Deepak, you can unshare your screen.
Okay.
Okay, so here the thing is you are not able to communicate from R7 to R5, right? The branches?
Yes, Kalyan.
The customer B branches, they are able to communicate, is it?
Yeah, B2, customer B2 is able to communicate with customer B1.
Okay, fine. Okay.
Bi-directional, there is no any issue.
All right. And one moment, I'll just open up let it come up while we solve this problem. All right, so let that come up. Okay, so again, confirm please. You're able to see me type this enter key. So
Yes.
okay, all right.
Kalyan,
So
I was
111 is
asking,
there.
are you able to hear me? Yeah.
Yeah.
Kalyan, actually, I was performing this lab on my own laptop, just over the GNS. So every time machine CPU is showing 100%. So
Okay, what's the memory in the processor you have?
yeah, it's 8 GB RAM.
8 GB should be fine, no problem. No problem. So in that case, idle PC is helping you?
Yeah, in middle of the lab, most of the time I just check for the idle PC and I set the idle PC. Then this GNS will come under the control and it shows 50-60%. But apart from that, my own machine is showing 100% CPU.
Oh, then the capacity of the PC is that. What you then do is cut down the number of routers. You don't have to take them out. You just shut down those routers and the performance of the system should be a little better. Something which you're not using in the right environment right now, you can shut them down.
Okay.
10 routers is the reset size. Right?
Yes. Thanks.
Yeah. All right, so we have this R5 connected is 7 and 111 is the point of interest to us. We have that information and show IP interface brief. We have 7. Okay. That's the networks. So next thing I want to check is R7 itself. R7 to R5, we want to check the connectivity first. So R7 show IP route should be a plain vanilla default route pointing towards serial 1/0 and show IP interface brief 3332. That is fine. The 3332 is not in your routing table. 33 is not here. So you cannot ping from your WAN interface. You can ping from your 1111. So ping what is this IP? 50.50.50.50. 50.50.50.50. Source it from your loop. Totally unreachable. So that means your router R1 doesn't have it in its VRF table. R1 does not have it in its VRF table. So about A1. I need to see them as BGP routes. I am not seeing 50-50 here. Okay, so you did not configure, no, not 50-50 is coming from the other side, right? So it is not in the BGP routing table. So why is it not in the BGP routing table? A proper import exports are not configured. Show IP VRF brief. I can, there is no import export. Fantastic, problem solved. Okay, so on R4, I want to see what is the export statement. That is important. R4. On R4, whatever you are exporting for this A3, that must be imported on R1. R4. So,
Kalyan, I'm connected now.
Yeah. Huh? You're?
Yeah, I'm connected now. Actually, I got disconnected. There was a network glitch. So.
Oh, I'm sorry. I did not even know that. Okay, I thought you were watching it. Okay, the problem is here. The problem is R1, you did not have any export and import route targets.
I configured route target 5:5.
No, that was on R4, but I'm not seeing it on R1. R4, I see that export is 5:5. So I'll simply have to go here, go to this. So
If you remember, you told me to configure on R1 initially when I was not.
Wait a minute. There is this -A1, and that is what you're seeing here, -A1. But you're supposed to have it in A1. Okay, 1 second.
Oh.
There is this other thing called A1. Okay, so here this is the mistake. No, not that one. No, that has nothing to do. This has nothing to do. You're not even using it. No problem with that. Okay, I'm checking on this. This is the one. Here on R4, you said export 5:5. So on R1, you should import 5:5. Okay. So that is what you're supposed to import. So I don't know why you had 6:6 also there. But looks like you have an import statement for 5:5 also.
Yes, I have configured both actually, import and export on every router.
Not that. The export values are important. Okay. And looks like you did import 5:5 here.
Yes.
Okay. So if you imported 5:5, you must have that in your VRF routing table. You don't have it. So the next check I will do is it in my VPN v4 or not on the other side? If on the other side, if they have done it correctly, I should get it. Show IP, BGP, VPN v4, all. It is stuck.
Yeah, it should work. Otherwise, it will take minimum 10 minutes to come back. Yeah, and I'm really fed up with this GNS actually. Every time 10, 20 times I assign the idle PC value. Thereafter it works.
I can see a very, very clear disappointment with GNS. Multiple times you said that.
Yeah, each and every time means I have to assign that.
I love GNS, everything. Grand.
The way it works, I also love it. But when it gets stuck, so
what is it? That's it, huh? So you just have to wait for 5-10 minutes. Is it?
Yeah, and we have idle PC value actually. Could you?
No, there is no problem with this idle PC. Server CPU is fine, CPU for the VM is fine, GNS is fine. That's not the issue. It's just some cranky thing. Let me close the console just like that and try to open the console.
So, Kalyan, the root target value means like 5:5 in this case means it should be means same on both routers which belongs to the same customer.
Yes, export and import are the key. One side you export, you are adding the community tag, and the same thing should be imported on the other side. Now looking at this, I don't see a problem with the export import because on this side, which is A1, you imported, and I saw on the R4 already. I saw that you have exported 5:5. Okay, so import and export in this case should not be a issue. So the second question would be now, okay, on R4, do you have it exported correctly? If you have exported correctly, it would be in the VPN v4 routing table of PG.
Yes, it's there. Okay. The routes are there in the.
That is what I wanted to check. And if that is also there, Then,
Mm.
I mean, we will see if that comes up. Oh, now the system is hang, huh? Oh, no. Okay. So we will check that. And before that, oh, what is this?
Yeah, this is for actually now that router 4 is hung means it's not working. That's why neighborship is means router 1 has reset it that neighborship with router.
Oh, this is really a
Yeah.
GNS thing, huh? Yeah.
Yes. As
Show
soon as router 4 will come
run
up,
section BGP. I want to see whether you have activated VPN v4 between R1 and R4. That's what I wanted to check here.
yes, I did.
So for the VPN v4, what is that IP? R4 IP address?
R4 IP address 172.111
111. Okay.
and
So
3
for
belongs to
VPN
router
v4,
3.
you have activated and send community both. Why are you giving next hop self to this? Why are you saying next hop self? Not required. And A1, you redistributed the static dots here. Yeah, so looks fine here. So R4, you basically have to restart the router or what?
Actually, means you just assign the idle PC value. It will come up.
Oh, no. Idle PC is not necessary for this context because we can see there the CPU is way below 50%. Okay, so that is not the requirement. Looks like this router is hanging just like that. It is just hanging, I think. So if I stop it, and then if I start it, it should just start. Close this console. Okay. Yeah, I think that's just that one router creating the issues. Just confirm every time you are facing a problem with R4 or any other router randomly. Deepak?
Looks like Deepak is raising RMA for the R4.
Hey, this is looking like
Yeah,
a
if this
GNS
router
issue.
had in our DC environment, then definitely I would have been RMA for this.
Is it only this R4 creating problems multiple times or multiple routers randomly?
No, multiple, randomly. Sometimes router 5 does, sometimes router 8 does.
Yes,
And I'm spending hours and hours.
this is definitely a GNS thing. And I never had a problem like this. I don't know why. Maybe one time, I don't even remember. Maybe. I just have to delete the router and put another router and that's it. This has nothing to do with the ideal PC also because you can see it's performing good. Both the VM and the thing. Okay. Right. This is a waste of time. This is definitely a waste of time. I'm not good. So we will wait and
Thing we are performing. So in by doing so, we are just spending so much time. So is there any other tips which you can give us to just sort out the time and just fix the issue quickly?
No. No.
Mm-hmm.
Very famous. This is very famous. It's a pain in the
Storm control
place.
is there, I think.
Yes, storm control.
No, it's not a problem about
No,
the
no.
storm control he's talking.
Storm-
He's talking about
yes.
a problem in the switched environment.
Yeah, switching environment. Yeah.
Yeah.
Suppose you have 100, 200 switches and somewhere a loop has occurred and you are just searching where it is. So sometimes it just give us too much pain. We are just searching one by one from core to distribution and access everywhere. We are just checking the STP status and such kind of thing.
Neelam,
You check the STP status. You check
I would like to
processing
share my
capacity.
experience actually.
Yeah, please go ahead.
Once actually I faced this challenge. Once I faced this challenge actually, there was a building, 6-7 floor building.
Okay.
So suddenly there was a burst or flooded the means of MAC addresses. So a whole network got down actually. We were not able to access our devices, even core devices, distribution and access devices. So what I did, I went to the means devices and I connected my console cable. Even I was facing while connecting console cable as well. So and the entire network went down that time.
No,
So what I did, I had.
Yeah, I mean,
Yeah.
so that how did you come
I'm
to
coming
that?
I'm coming on that.
Okay.
I'm coming on that. Actually, somehow I connected via console cable and I just checked the logs. Actually, I was connected through console cable, so I was getting some logs. Based on that log, I got to know that there is a loop in the network. Actually, some MAC addresses were learned from one interfaces and sometimes on the same MAC address on other interfaces. So what I did, I had to remove the every cable on the core switch, and I just connected one by one. Then I got to know that there is a loop on that floor. So I removed that cable and immediately I configured storm control. That's why I was asking to Kanyal what is the best practice. I configured that 30% level that time. So what it did is just the port means where that hub is connected, we were getting the loops, immediately shut down that port. And everything got means stable that time. And when I went to that floor, I just explored that hub. I removed that hub and then I sort out that problem.
Right, Deepak. Yeah, usually we used to perform such troubleshooting when we are observing the issues of one by one, whether we are just removing the cable from the core and distribution end. So by this we can do, but what
if you configured storm control interface basis on your all and host interfaces, so as soon as if anything hits to that port, like if some hub is connected or somewhere means something happened wrong, the port immediately gets shut down.
I think
That is my personal experience.
For that you can configure loop guard and such things. So
No loop guard. Storm control is different. Loop guard is different actually. Storm control, you can configure storm control for broadcast, multicast.
Yes.
All right, guys.
Okay.
The thing is, what you're telling Deepak is an issue that you have faced because of broadcast storms, and there was a hub in the picture, and therefore there is a very likelihood of the loop being formed. And even in your case, what you have basically done is remove all the cables because you were able to get a console access, and one by one you were checking. And this is exactly what he was also doing in an environment where he could not figure out where the loop is. They had to go switch by switch and check it. So the question asked was, is there a very easy or at least a guidance principle on how can I get to the problem easily? And the one word answer is, it is not possible. Okay, the problem he faced and the problem you faced are two different things. There's no easy solution to this. And this is a very famous requirement, and unfortunately the answer is you have to go step by step. The logical reason for that is STP is automatic process. If there is a configuration mistake somewhere, I can pick it. But because it's an automatic process, the one thing which you do is follow the root port. Okay. And when he said that he was going through the access distribution, he implied that he's following the root port, right? You're going towards the root slowly, one by one switch after the other.
Right.
Yeah. So that's the only method. Unfortunately, there's no quick way of identifying. And that too, yesterday I was explaining you a scenario, right? Maybe there's a problem on root switch and the neighbor, but you may see a flap on some other place. Okay, very difficult, almost an impossible thing to do, one by one, step by step. Okay, we look at the processing capacity. Okay, some device is having a high-end processor.
So yes, in that case, CPU will get high. So
yes. So we get a high process. So we just try to take out one cable at a time. Yeah. Okay. And very soon, I hope STP should become history. You know, we should not be able to deal with STP. STP should not be there in the environments. Now it sounds ambitious 5 years back, but now it is just becoming reality. Okay. So yeah. Let us get to the, data center switching stuff. Okay. So everybody able to see the screen, right? Yeah. Yes, guys, confirm?
Yes, good.
Okay, good. All right. So what is this? Why do I need this? Now, here is the thing. Enterprise network, enterprise switching, and data center switching, from a physical connectivity perspective itself, they are a little different. Okay. Now, enterprise is basically your campus, right? No, take it to a big extent. It could be a LAN, doesn't matter. Now, end of the day, what you are doing with an enterprise network, you are serving your client, like the cubicles of your company, a branch office, a banking sector. So the cabling will be huge, like the cabling will cross the floors, it can cross buildings. There are different access points you connect, wireless expansion will happen if your company decided to have this wireless stuff. So enterprise is a scattered network. Okay. Even though there is one network room, building by building, floor by floor, endpoints are scattered. So your cabling expands to a greater extent. But that is different from data center switching. The data center LAN itself is consolidated. Okay, that's the whole point of a data center, right? It's all consolidated to, maybe a building, maybe a floor, maybe a big floor with, I had the opportunity to see one data center which is like, 17 racks in a row, and there were about, I think, 8 or 9 rows, and that was in like 3 floors, sorry. So it was humongous, okay. The whole data center is consolidated network. You are putting all your resources, servers, applications, firewalling, all the services of the network, everything you put into one consolidated place. Okay. So from a physical connectivity perspective, okay, there is no end devices there. Okay. The end devices are all out of your network. They are coming from internet. They are coming from intranet. If it is a private data center, your other branches are coming into this data center. So everything, all the end hosts, like the servers in the data center, they're all consolidated into one place. So when they're consolidated into one place, we need to understand how that data center physical designs look like. There are a couple of designs which people follow, and those are the only two you can possibly see. Top of rack and end of row. Now, what is top of rack? You have your racks here, like I don't know, depending on the size of your network, plethora of racks you can have, doesn't matter. What happens with top of row is you will have one or mostly two switches to which you have your servers, most likely two NIC cards. If it is an ESXi kind of a thing, for some reason they wanted 4 NIC cards. So what you do is you connect one of the cards to one switch, the other card to another switch. This way, if you have like 20 servers in a rack, you will basically connect 40 cables, 20 into 2, 40 cables. And if I say ESXi, that could be 20 into 480 cables, something in the range of 40 to 80 cables. And obviously, one set of cables you are going to connect to switch one set of cables to connect to switch 2. And then you have your uplinks. Maybe, no, this is, I don't know, maybe 48 port, 24 port. So then you will have like 4 cables, just as an example. It could be 8, it could be 4, it could be 2. You will take these 4 cables and then you connect them to the distribution switch, we call it, right? We connect it there. Now this happens both for network, and if you happen to have a storage network, you will have another set of cards. We call them HPA cards. You connect that to another pair of switches. And then from there, your storage network will also start. SAN will be on one side and the LAN will be on the other side. And this repeats itself for all the racks you have. 10 racks, 20 racks, doesn't matter, I don't care. So this is the top of row network designs. When it comes to the other design, which is the end of row designs, what happens is, again, you have your racks. Again, you have your servers, the 20 servers I was talking about. You have again 2 cables or maybe 4 cables required, because 2 ports or 4 ports, depending on what operating system you're running. And then what happens is you don't connect it to any top of rack switch. Now, if you go for cabling, you know that there will be a patch panel. Okay, so it looks like a switch, but it's not a switch. It's just a physical terminator. That's it. So you connect it to a patch panel. But the point is now, like 20 into 2 or 20 into 4, 40 to 80 cables will go from each one of the racks directly to the end of row switches. There's no switch I use in the top of rack. I don't use that. Okay, so you have this other model of connecting physically to the end of row. So the first one is the top of rack model and the second one is the end of row model. Okay, that's pretty straightforward. I mean, easy to understand, I guess. What is the drawbacks and advantages of each of this? When it comes to the top of rack, the major advantage you get with top of rack is that you have less cabling to do. Okay, there is less cabling to do. Now, this itself looks a lot of cables, right? 4, just optimally saying 4 uplinks you take from each rack. And by the way, I'm taking 4 from each of the switches. Okay. And let us say I'm taking 2. So let us keep it simple. So if I take 2 from one switch, 2 from another switch, that would be 4. And if I say I have 10 racks like this, that would be 40 cables terminating to this distribution switch. Now that itself I'm saying less cables. Because if I go and compare that with end of row, I mean, oh my God, 80 into 10, 800 cables are terminating to this end of row. Of course, there are 2 end of rows, so 400 cables are going there. I mean, that's a lot of cables. So the major advantage you get with top of rack is less cabling. Now it looks like a very simple point, okay, less cables. but it's a very, very important point. See, from a data center perspective, every square feet matters. Okay, when people purchase place in the space in the data center, it's almost like a rental place, right? You take it on a per square feet basis. If I have to put 800 cables, like what you see in the end of row, the amount of space you need to lay out those cables, that itself is humongous. Again, you may put it under the floor, or you may take it on top of the roof. The cables, you can take them on top of the roof. Right. So, just to accommodate these cables, I need a bigger space, and that leads to the capital expenses. I have to, if I'm building my own building, I have to accommodate for that much of space, which is a capital expenses. Second, because the room sizes are increased now, you have to follow certain rules. There is a certain temperature through which it has to go. There is a certain air flow that has to be there, because otherwise your servers will not have the necessary cooling. Okay, so it looks like a very simple bunch of racks and a bunch of servers, but a lot of things go inside. The rack can have airflow like this, top to bottom. The airflow can be side to side. Your servers will also have airflows, top to bottom or side to side. Lot of things you have to take into consideration. If your server's airflow is side to side, and if you have a rack where your airflow is top to bottom, the cooling will not be proper. So a lot of things. And again, if I have to follow the ISO standards and all, every server, every room, everything has to be in a particular temperature, not more than that. So a lot of things come into play. It's not just put it there and just run them and let it work. No. So, because the room sizes increase because of the cabling, capital expenses increase, and because of the room size increasing, I have to increase the corresponding temperature management, like electricity bills will be increased. In order to maintain this airflow, air circulation, I need to have special fans put on in my data center. Special ventilation systems I'll have to put. And that leads to operational expenses. Every month you'll have to pay the rent for the houses if you are renting it. Otherwise, you will have to pay every month for the electricity bills, which keep coming up. So it looks like less cable, more cable, but that's a humongous expenses. And take it for a monthly, yearly basis, and for a decade you are doing it, that costs a lot. So the advantage, which is a very, very important advantage you get, is less cabling. What is the advantage of end of row? The advantage of end of row is less management points. Like you have 10 rows, I said. 20 servers, I said. That's 200 servers. How many devices should I go and manage in order to accommodate all these 200 servers? Well, maybe 2, maybe 4. If there is not port density here, maybe 4 I'll have to accommodate. And that's it. Tomorrow I want to put a server in a VLAN. Tomorrow I wanted to do storm control. Tomorrow I wanted to apply some security. Tomorrow I wanted to provide routing. Any of those factors, I will just go into these 4 switches and I will just configure. That's it. All my 200 servers are managed with this. So I get less number of management points here, just 4 as a random example. How about here? Now I said there are 10 servers. Each server has got 2 switches. So that itself is 20 switches. And then I have 2 end of row distribution switches. So that's going to be 22 switches. Tomorrow, if I have to add a single VLAN, I'll have to basically go into all of these 22 switches and configure the VLAN. If I wanted to apply a port security on something, if I wanted to apply some ACL on something, if I wanted to provide a gateway feature on something, I'll have to go in and configure those respective things on multiple management points. I'll have to go to each of the switches and configure them, which server is connected. I'll have to go to that switch, that server, and configure that. It's a lot of management overhead for me. It's a lot of management overhead when it comes to top of rack. Okay, so the less management points becomes a drawback in top of rack. The less cabling becomes a drawback in end of row. Anybody making a guess on why I started discussing this? Maybe anybody knows where I'm going with this?
Facts and other facts and.
So Cisco came up with this line, not EtherChannel, not at all. No. Cisco came up with this idea of, okay, how can I take the advantage of less cabling? I need less cabling. At the same time, I need to have less management points. How can I get both of them? And this is where Cisco came up with another line of products. They call them as FEX. Fabric extenders, we call it. Suddenly, our LAN, we don't want to call it a LAN. We want to call it a fabric. Okay, this is actually a term in storage networking. Storage people, they don't call it as a SAN. They call it as a fabric. We call it LAN. That is our traditional name. Now suddenly we say we want to call our LAN also fabric. Okay, fine. Everything is a fabric nowadays. So fabric is nothing. It's just your local LAN. It's a new terminology. Mostly some new devices and new technology running. Okay, but otherwise it's just your local LAN. Nothing else. Now they remarketed the LAN, calling it as a fabric. So what is this? What is this FEX? First of all, the Cisco's 2000 series, 2K we call them, Nexus 2Ks. These are all the series of FEX models that you can see. Again, depending on the models, you have port densities. You have 24 port, you have 48 port, you have 96 port. So I'm not going into the product specs and all, but you have these FEXs. I want to understand what these are. Like, ultimately my goal is this. I wanted to have less cabling and less management point. So this is what FEX does for us. What happens is, if I have a rack, I will connect two FEXs. And all my servers are going to be connected to the FEX. So it is almost like, not almost, almost like connecting to the top of rack switch. It is not a patch panel, okay? It's a top of rack switch. And then you have fabric ports, we call them. So within the FEX, you have what is called as access ports. Don't get confused with our access port. Huh? Here the access port means the port connecting end devices. So this access port, you have this FEX. These are connecting to the end devices, the servers. This port can be an access port or a trunk port. Don't get it wrong, okay? Unfortunately, they use it the same term access port, indicating you connect to the end devices. And then you have fabric port. The fabric port is the one which is typically on the back side or maybe on the side of it, depending on the models. This is the one which I connected to the end of row switches. Okay, so you have these fabric ports which will terminate to the end of row switch. The end of row switch could be a 5K, Nexus 5000 series, or a 7000 series, or a 9000 series, whatever it is. So from a cabling perspective, you have the same 10 rows and then you have these 20 servers. Now, just like the top of rack, you will have less number of cables. You only take the uplinks from the fabric port of the FEX to this switch in the distribution. Okay, so I'm getting less number of cables. But what about the management? Now this is where FEX is different from a regular switch. See, once you connect your FEX to the switch here, we call this as the parent switch. We call this as the parent switch. Once you do that, you have your 5K, for example. So this is the physical topology. When it comes to the logical topology, it looks like this. You connect your FEX to this 2K, the FEX. You connect it to this switch. Now this switch is now called the parent switch. What you do and how you connect is a very, very simple thing. From a configuration perspective, you go inside these ports and say switch port mode. You have access, you have trunk, right? Now you have this thing called switch port mode FEX. FEX fabric, we call it. And then what you do is you give a FEX ID to it. So you give an identity number to this. Let us say I gave an identity of 101. Okay. Now here is the thing. You have this connected to 1/24, 1/25. These are the ports of the 5K. Okay. And then there are other ports also, right? 1/1, 1/2, so on. You called this FEX as 101. Right. So this has got another set of maybe 32 ports, 1/1, 1/2, 1/3. This is what happens. Once you configure the FEX mode and once you give an identity to that, when you give the command show IP interface brief or show interface brief, in Nexus, when you say show IP interface brief, it will only show you the layer 3 interfaces. So you have to say show interface brief to see the layer 2 interfaces. Small differences, but yeah. When you say show interface brief, you will see Ethernet 1/1, 1/2, 1/3, blah, blah, blah. And then 101/1/1, 101/1/2, 101/1/3. If you have 24 ports, you will see 101/1/24. What happens is, once you connect the fabric extender, the FEX to the parent switch, by just giving those two commands, that's it. By doing that, now this particular FEX will be treated like a line card, like an extended line card. It's almost like you have a modular switch and you're connecting another module. When you connect another module, suddenly you get this 3/1/1. You connect another module, 4/1/1, 4/1/2. You suddenly start getting these extra interfaces, right? Exactly the same thing. So if I have connected these 2Ks on each of these switches with 4 cables, like what I gave here as an example in the top of rack, now how many management points are there? If you connected them to 2 switches, if you connected them to 5 switches, only these are the management points. As a matter of fact, you don't have a way of going into this 2K and configuring anything. You can't do that. Locally, you can't manage it. It's just a fabric extender, almost like a line card to the parent switch. That is what they did. They tried to accommodate the advantage of less number of cabling by providing them like top of rack switches. And then they also gave the advantage of managing those fixes, managing those top of rack switches using a single point of contact, the parent switch. So anything I want to do on this interface, I want to configure as a trunk. I want to make it a port channel or a VPC later. Whatever I want to do, I can do it on those ports just by logging into this switch. So this way, imagine I connecting to like 10 of those FXs. So suddenly there is only one management point to basically configure 10 into 24, 240 ports. All I can do it in one switch. That is the advantage of having FEX. There is a methodology followed. And one of the famous examples for one of the famous advantages we say for FEX, licensing, upgrading. Okay. So now because the FEX has become the extension of your line card, extension line card to the parent switch, what happens is as soon as the FEXs come up, as soon as I discover the FEX, immediately it will give a IP address to this FEX. This is something which we don't see. It happens automatically. And here is an interesting fact. It gives an IP address in the range of 127.15.x.x. We say that 127 cannot be used at all, but they use it internally. So it gives 127.15.x.x IP, one IP address in that range, and it will check. Okay, my version is 6.3, your version is 5.3, for example. Because there is a version mismatch, I am going to automatically upgrade this version. If this is 5.3 and this is 6.3, even then, I will overwrite with my version. So parent switch version is what it will take. So it will override, upgrade the version, and then bring all these interfaces up. And if you have already done some configuration, interface 101/1/1, switch port mode trunk, switch port mode access, trunk allowed VLANs, whatever you have done, all of those will be applied to this particular FEX. Okay. So that is the advantage we get by having a FEX.
So Kalyan, these FEX cards will be supported only on the Nexus series switches.
Yes, right? Yes. FEX card, you don't say it. FEX switches. They act like cards, but they are actually the switches which we put on top of rack.
Okay. Are we going to install this FEX module on the Nexus switches, or it kind of switches we will connect the cable?
That is the point. Okay. They act like line cards, but you don't attach them to this 5K. These are separate switches which I put on top of rack.
Okay, it's kind of switches on top of the Nexus 5. Let's say I have Nexus 5K. On top of that, I will put this FEX module. Just like a switch, I will insert it and then I will connect the cable from FEX to Nexus 5K.
Yes. Insert where?
Top of the rack.
Very good. Right. Correct.
And what about, is there any, apart from FEX, is it possible to insert the line card in Nexus 5K also?
5Ks are not modular, but again, by the time I say this, you may see a product in 5K which is modular, but typically no. 7Ks are modular.
Okay.
You can also add line cards, just like your Catalyst 6500 series switch, for example.
Okay, line card is nothing but additional ports we may get it, that's it.
When we say line card, it is in the chassis. Like you put it here, line card, you put it here. When it comes to a FEX, you take the port and connect it to a FEX separate. This is a separate switch.
Got it. Okay.
This will now, for example, line card, if you add in the module 5, it will be module 5.0.1/0/2, so on, right?
Yes.
Line card. Now, when you add a FEX, which is external switch, if I give the name number 101, now this will act like 101/1/1, 101/1/2. It will act like a line card, as if it's a line card.
Got it. let's say when we say flex means it's an external switch, like that we can assume.
Exactly. Not assume, that is the fact. That is the external switch.
But line card is we will be inserting inside the chassis. That's the
Exactly.
difference.
Exactly.
Okay, got it.
Okay.
But
So,
Kalyan, 7K itself having so many number of ports. So what is the need to just extend? I mean, for this fax concept.
very, very, very good question, but I already gave the answer to the question. See, the idea of having a fax is not to increase the port density. Port density is an advantage. Okay, I get it. But I can get port density, as you said, by adding another line card or by adding another switch. I can buy another 7K, no? The need for a fax is not to extend the port density. The need for it is to have less management points with less cabling.
Okay.
Yes, there is a 7K here. Yes, if I want more ports, I will add a line card. But that's not my challenge. I have to take the cables from here to there.
Okay.
If I have a fax, I will just connect it to this here.
But on 2K, there will be like 24 ports, 48 ports as per the model. So there
Yes.
also we will have the suppose 24 ports or 24 cables will be there
Yes.
for end users.
Yes.
Then how we are simplifying the management? Okay, so you mean to say that we are managing it from the parents with like Nexus 5K? Okay,
Very good. Now you got it.
Okay.
I don't care how many faxes are getting connected. That's why I gave this example. If I have 10 faxes, I connect it to this one 5K, all of them will look like a line card for me. This fax is 101, 102, 110. So I will see 101/1/1, 1/24, 102/1/1 to 1/24. All of that I will configure by logging into this. That's it.
Okay. So by doing so, are we increasing the backplane capacity as well?
Pipeline in the sense of
Like adding a fax?
pipeline. What did you mean by that? Because it looks like a dangerous word for me.
No, not
Pipeline.
backplane. I'm saying backplane.
Backplane. Very good. Yes, you are increasing it.
Okay.
Yes. Okay, that's a good catch.
Kalyan, could you please elaborate this process 127.15? Means,
Once the fax is discovered by this parent switch, it will give an IP address in the range of 127.15.x.x. It's almost like working like a DHCP server for the faxes. Once it gives the IP address to this, then it will look for the version of the firmware on these faxes, and it will automatically match the version of the parent switch. And once that is done, the configuration which you have applied to those ports is pushed to those interfaces. That's it.
okay, so that this IP address is used between the parent switch and fax?
And the fax, correct.
Okay, and so if there are any other faxes, so there would be a multiple IP addresses in the same range just to identify that fax.
That's all. We don't even see that. We don't even ping test.
But we have assigned the fax ID as well.
Yes. That is the one which is used to identify the ports of the fax. If I give 101, then these ports will be identified with that. It's like a module line card ID I'm giving. It's like that. Yeah.
Kalyan, I have one query. Let's say I have one fax that is connected to 5K 10G port.
Yeah.
So each port on the fax have different like speed 10G, 1G. So its throughput is
One
distributing.
second. You have a 5K with a 10 GB connection going towards the FEX.
Yeah. So
Towards the
I'm
access side,
Yeah.
Towards the access side, you have 1 gig, 10 gig capacities, is it?
Yeah.
Okay.
So my main bandwidth is 10G. And below fax, all the devices connected via 10G or 1G servers. So my bandwidth is here distributing. So is there any throughput related issue
Yes.
we can face?
Yes. And I also have to tell you, which is the upcoming topic. This is the physical connection. Management wise, it's okay. But how about switching? How about the data paths? What will happen there? So I need to first know that.
Okay.
With FEXs, there is no local switching. Now this hurts a lot of people. What? 5.5, 5.6, they can't talk to each other like this? No, they can't talk. If I have to talk from 5.5 to 5.6, I'll have to go to the parent switch and then only come here. The local switching is not possible in the FEXs. Now your question becomes even more important, right?
Yeah.
Yes. So it's a very important point. So when you are providing this provisioning here, you have two things to take into consideration. The total throughput you will expect inwards should reasonably match with the uplink capacity. It should reasonably match with uplink capacity. You should also take into account the round trip traffic. What if there are too many systems connected here which are interested in talking to each other? So not only that you have to take the outgoing total out capacity, but sometimes traffic goes back and forth here itself, right? That also you should take into consideration in determining the fabric uplink pipe. Okay. Reasonable to say, very reasonable to say, the ports connecting to the servers are going to be 1 gig, very common and very reasonable to say. And the uplinks which you have typically will be 4 ports. Typically, again, I'm not saying this as a rule, typically 4 ports, and all the fabric ports will be 10 gig. If you go with that typical setup, incoming would be 24 gig, outgoing pipe will be 40 gig. It's a fair bet to say there is no over subscription. It's a very fair bet to say that. Okay, but for the sake of argument, if you give the example of 10 gig and 1 gig and 10 gig and all that, make sure you have that much of capacity out. Now you also know another point, you also should make sure that you have extra capacity for local switching to happen. Because they don't happen, you have to go to the parent and come back using this backbone. Okay. Are we clear? Yeah?
Yeah, got it.
All right. Now, one more thing I want to highlight here with regards to switching. See, okay, now local switching won't happen. I told you. Oh, what if a frame is coming from here? What if a data frame is coming from? Okay, let me take a little cleaner example. So, what if I have my 5K here and then I have like 4 ports connecting to my 2K? There is a system trying to communicate, data is sent. Okay, which port will it send? 25, 26, 27, 28. Which port will it send? STP is running on this? What? Right? So these are questions from the data plane. How will that happen? So for the 2Ks, the fexes, there is no STP running, no STP. Okay, so imagine, see how much we are moving away from STP. So right now the access layer, if you buy all Cisco fexes, there is no switching in the access layer. I mean, no STP, sorry, no STP in the access layer. So we're avoiding that completely. Okay, then the question becomes even more interesting. Okay, if STP is not running, then how will the data be sent? You have two options. The default is called MAC pinning. Again, this is one of the new styles of communication in data centers. And you see this in a lot of other places like UCS, stuff like that. What is this MAC pinning? What happens is, this is the default, by the way. Okay. What happens is, when a frame comes, the 2K, looking at the MAC address on a per MAC basis, it will dynamically pin to only one uplink. So anytime I get data from this particular MAC 1A, I will send it on that particular port. Similarly, if a 5K sends the data, okay, 5K sends the data for some reason to any other port, I won't even accept it. Okay. So this is done very dynamically and very simple logic. No STP, nothing of that sort. If a MAC address is learned, I will dynamically pin it to an uplink, and anytime I send the data for that MAC, I will send it on that uplink. Anytime I receive data for that MAC, I will only accept on that uplink. That's it, job done. So another MAC address comes up, though I will pin it to some other port, generally round robin, but dynamic. Okay, it just picks up on the next available uplink and pin it. This is the default and this is the way it works. This is one way of allowing things to happen. The second choice you have is, we still did not discuss the details of it, but at least the basic I think. You can configure a port channel. You can do it. If I do a port channel, then I can start load balancing within that port channel. Okay, again, our load balancing methods and all that stuff we will discuss in EtherChannels. But yeah, this is another way of doing it. By simply configure this as a port channel, you can allow communication to happen. Now at that time, you are going to load balance between all the ports. So these are the two ways in which you can switch from the FEX to the outside world. Are we clear with that? Okay. Right.
Kalyan,
So,
please let us know about static pinning. Means what is the static pinning and what is that?
Static pinning is you taking control of which MAC addresses will go on which uplink. That is what static pinning is all about. What I have told you is a dynamic pinning logic. It just automatically picks generally on a round robin fashion and it does that. But you can do static pinning by saying this MAC will go to this particular pinned uplink. You can control that. That's static pinning. Okay.
And for this MAC address, the process will remain same, right? The aging time, MAC entry, everything, or
yes,
is there any certain time period? How long this?
Yes, the MAC entries are not in the 2K. Remember that? Remember, 2K is not doing any local switching.
Yeah.
The MAC addresses are here and the timers are as usual, the regular Nexus. Typically, I see 1500 seconds the defaults for the Nexus, but again, depends.
If I move the cable, let's say it is already lent updated the MAC pinning, immediately if I remove the cable and connect it on different port, it will not support. or actually it will bind.
Whether there is a failure, for example, if this link goes down, right? Or what you said, you just remove the cable and put it to something else. In either of the cases, all those that are pinned will be repinned to another uplink. It could be a failure, it could be just removal of the cable. I mean, for the switch, it's the same effect.
Okay.
So it is without EtherChannel, Kalyan, correct?
Without EtherChannel, keep that in mind. One option is configuring port channels. The other option is MAC pinning. If you go for MAC pinning, that interface will only, that MAC address will only use that uplink. If I configure port channel, then everybody can just load share the entire pipe. In this case, the 40 gig pipe or whatever. And that becomes a regular load sharing of load balancing of regular Ether channels.
So in case of static pinning, if my uplink which I have defined that got down, so my connection will just lost for that server?
Yes. If I have done the static pinning, in that case, the connection is gone once that uplink is gone. Okay.
So there will be no any automatic selection election because in dynamic MAC pinning, yeah.
Because you decided to go for a static pin, it will not happen.
Right.
Okay. And again, then how do you solve the problem? Again, I did not still talk about it. We will have this concept of a VPC, wherein here you provide a static pinning, here you provide a static pinning. So if this goes down, then this will be down. However, you will have an alternate path. So, I mean, in one word, you have to find alternate ways. Switch 2K will not help you out. That's the point. Okay.
So, Kalyan, in that we shouldn't configure static pinning in our network because if one uplink goes down, so traffic would not pass through that.
Okay. The better way of asking the same question is, why do I need static pinning? Right. There is only one reason, which is, in my opinion, theoretical, but there is a reason. The reason is, see, I have one server which needs, like definitely needs 10 gig capacity. I don't know. Maybe this system is a ESXi, which has got some very, very important servers. All of them are very busy. I don't want to share the bandwidth with anybody. I don't want to share it with anybody. So I can do a static pinning of that MAC address to, for example, this particular uplink. I'll do that. If this fails, I don't want to go to any other card. I don't want to go. Again, I want that 10 gig. Dedicated, we call that as deterministic traffic pattern. I want the 10 gig for that server. So what I will do, I will find an alternate way, maybe some technology like VPC or whatever, or simply 2 NIC cards to the server, active standby. Like I can do it with multipath, not multipath we say, load balance I can do, okay. Multipath is for storage. So what I will do, I will create another path. You don't worry. Network, if this is there, give me, otherwise, no, this is gone, the link is gone. So once this link is gone, at the operating system level, I take this as the primary now. The backup becomes the primary. So here also I will do the same static mapping. So why am I doing this? Because I wanted deterministic traffic flow. I don't want to share with anybody. So this is the reason why I should go for static pinning. Said that. Realistically, it's too much. Okay. I won't need it. Generally, as I said, you will have a 40 gig connection, you will have a 24 port. If you happen to have 48 ports, you generally will have 80 gig connections. So generally the proportionate uplink will be there. You want more resiliency. redundancy is what you want. Static pinning, you have to find alternate ways, and that's what Deepak was asking. Then why should I go for static binding? Because then resiliency is lost. If this link goes down, the NIC card will look as if it's down. Yes. So that is what mostly we want. It's not like bandwidth is not important, but generally speaking, bandwidth will be available. Okay. So now you know that trade-offs with static pinning, you just don't have resiliency. You have to find resiliency in other alternate ways. With dynamic pinning and with a port channel, you're going to get resiliency. In real world, I would say 9 out of 10, 99 out of 100, people will simply put a port channel. Okay, they don't even use dynamic pinning. They'll just put a port channel so that load sharing can happen properly. So that's the thing. Okay.
Yes, clear. So Kalyan, can we say that pinning is that we are binding any server or system to the particular uplink? Exactly. That is pinning.
Yes.
Okay. Thank you.
All right. Numbering, and then you start configuring as if they are really connected to your switch itself, like extra line cards. Okay, there is another technology they brought up called VDC, Virtual Device Context. They brought this called Virtual Device Context. Now, I have to cover this because it's there, really. Okay. In real world, I never heard anybody say I am using VDCs in my environment. Okay. Thank God you told me. Okay, because I wanted to say something. Okay, so it may offend some clients. So that's why. Okay, all right. So yeah, there is only one reason to use. Okay, if I don't have money, to buy 2 boxes. Okay, if I wanted to save my capital expenses.
Absolutely, my parts
Huh?
Absolutely, my parts and the
Okay. So yeah, so that is the reason. That is the reason why we do it. And who uses VDC? The lab providers will use VDC. Seriously. Okay. So testing, yes, you can use the VDCs for that. But first, let me tell you what this is. Right? Many people compare the VDC with the VRF concept which we have learned, and I totally disagree with that. It is wrong. Okay. Let us try to understand VDC as is, what it is. See, here is the thing. You have your box, right? You have your physical boxes, and the VDC is a concept that is supported only by 7Ks. First of all, let me tell you that 5Ks don't support VDCs. So it's only for the 7K devices, right? So what is this? See, you have different line cards here. Okay, different line cards. So maybe line card 1, line card 2, and then there is this line card 3, line card 4. And then you have a couple of supervisor modules. Maybe you added those 2 supervisor modules, 1, 2. See, this is just one box, right? Just asking you, How many operating systems are running here? It almost sounds like a stupid question, right? Or maybe because we are just getting introduced to this Nexus, maybe magically something will be there. No magic, just one operating system. NXOS is what you are running on this. How many ports are there on this switch? Or what do you mean? Tell me how many line cards are there. Okay, there are 4 line cards. How many ports are there on each line card? There are 24 ports. Okay, 24 into 4, whatever. I think 96, right? So those many ports are there. Okay. If I am running OSPF, if I am running ISIS, if I am running BGP, if I am running STP, how many processes are running? Only one process. What I do with the VDC is like almost literally divide this one physical box into multiple physical boxes. Like, no joking. It is literally like dividing that physically, not even logically. Physically, it's like dividing that box into multiple switches. The supervisor module is still the same, common. It is a common supervisor module. What you are dividing is the physical ports. Like I can say line cards 3 and 4 will be in VDC 1 and line cards 1 and 2 will be in VDC 2. When I create these VDCs, how many operating systems are there in the box? How many operating systems are there in the box? Make a guess. Your answer may be right, may not be right. Make a guess.
One.
2 operating systems. What? Yeah. 2. Once I create a VDC, you will be given a separate copy of the operating system and you can restart the operating system, you can restore the operating system, you can upgrade that operating system. It's a separate switch, like physically it's a separate switch. It's not like this VRF where if I create a VRF and run a routing process in the VRF, it's a logical routing table. It's not like that. It's not like a VLAN. It's not a logical thing. It's like physically you separated it now.
So then what if I do in admin VDC?
I will go there later. Okay. I still have to discuss the types of VDCs and all. Okay. So this is what I do. By creating a VDC, you are basically dividing the physical switch almost physically into 2 separate switches. That is what VDC does. And what we do is we put the ports in respective VDCs. So now, if I give the command, so I get into this VDC, I restart, not restart, I boot up the VDC first. And when I give the command show interface brief, how many interfaces will I see? Only the interfaces which I have configured in that VDC. Only those I will see. It's almost like a separate router. I told this so many times, separate switch. And I will say that again. It's so very weird. Now see this interesting thing. If I wanted a system connected to this VDC, maybe 1/25 or maybe 2/25, to communicate with a system connected to this VDC, which is like 4/2 or whatever, Can they talk to each other? Something in 2/25 trying to communicate to something in 4/2. These two are in one VDC, these two are in another VDC. Can they talk? Make a guess.
No.
No, they can't talk. Okay, but then how do they talk? I want them to communicate. This is 10.5, this is 10.6. I want them to talk to each other. How do you do that?
It is just like an interval routing.
Yeah, we think like that, right? No. For the first time, you will connect two ports of the same switch to each other. If you do this for any other switches, definitely next 5 seconds your CPU will go to 100% and that's it. Okay. But now you must connect. I mean, this is for the first time when I heard it and then I felt it, it was like, what? Literally, whenever I say VDC, whenever you hear the word VDC, think, literally you divided this into two switches, 7K. One I will call it now, with these ports, 4 and 3 modules. I created another 7K2, it's literally a second switch. Think of VDC like a separate physical switch. So if I say there is one port here, 4/2 connecting to this system, and there is another port here, 2/25 connecting to another system, if I want them to talk, if you think like these are two switches, literally two different switches, how do you make them talk? No inter-VLAN routing and all that, because inter-VLAN and all that is for logical separation, but VDC is like a physical separation itself. So if these are two devices, what should I do? I'll simply take one port of my first switch, maybe this is 3/24, connect it to another port of another switch. That is what I'm doing here. So if I'm running OSPF on this link, maybe I'll call it as a routed port. This is a separate OSPF, this is a separate OSPF. So you mean to say these two will form neighbor adjacency if I'm running OSPF? Yes. You mean to say if I'm running layer 2, they will run STP or RSTP. STP is not there. RSTP they will run. One of them will be the root port, one of them is the designated port? Yes. I already told you there is two separate operating systems running. So what happens to the control plane? PGP, STP, IS, OSB, whatever. They are two separate boxes. Physically treat them like two separate boxes. Now that's an amazing thing. What if I wanted to connect a port channel? Yeah, connect these ports like this. Remember, if you look at the box, physically this is just one box. This is just one box. But first time when you go, if you see this physically, what? You connected the same ports, 4 ports, 5 ports you connected. What is happening here? We feel crazy, right? That is the concept of VDC. You are separating them into physical entities. So with that said, what else do I have? When it comes to the VDCs, depending on the model and all that, you have maximum capacity. Okay. The maximum at this point you can have is 8 plus 1. You can have 8 VDCs. And what is this plus 1? Let me explain. Now, when you bring up the 7K, like for the first time, very first time when you start the 7K box, it will ask you one question one time. Do you want to have a default VDC? Or rather, I should say, do you want to have an admin VDC? That is what it will ask you. See, when VDC came into the picture, there was no concept of an admin VDC. There is no concept of a admin VDC. There was only one VDC that was called the default VDC, meaning all the ports of the switch were under the default VDC. It's almost like a global routing table or maybe a VLAN 1 kind of a thing. It's everything in the default VDC. Okay? That was when VDC came. So in the default VDC, I will have all the ports. And from there, I can create, depending on the versions, I can create 4 VDCs, I can create 8 VDCs. Typically, these are the two options you will see. I can create 4 or I can create, I know older ones used to create 2 of them, but either ways, 4 and 8 are predominant now. So I can create 4 or 8 VDCs. Now here is the thing. Because there is already a VDC called default, right? How many extra you can create? Well, in this case, you can extra create 3. In this, you can create an extra 7. So the default VDC is also counted as one VDC. That's also one VDC, which I can use. So let us say there is 24 ports, okay? 1 plus 1 to 24. There are 24 ports. So maybe I will create 4 VDCs. 6 ports, I will put it in 1 VDC. So I created 3 VDCs. But there is one other VDC, which is default. So total how many you have? 4 of them. So this is how it was before, like when VDCs came. Then they came up with an idea. Okay, we will ask the customer itself. When the switch boots up, we will ask the customer if they want to have an admin VDC. Now, if the customer says they want admin VDC, if the customer says yes, then there is no default VDC, okay? If the customer says no, then there will be a default VDC. In very, very simple English, you will have either admin VDC or default VDC. You will not have both of them. It will be asked when you get into the setup mode for the first time on the 7K switch. If you said that you want admin VDC, no default. Okay. What is the admin VDC then? What is the difference between admin VDC and default VDC? Here is the difference. The admin VDC does not have any interfaces. No interfaces are for the admin VDC. But in the default VDC, all the interfaces are in default VDC. They are in the default VDC. Meaning, I can use the default VDC, can be used for production. I can use this like a regular VDC. I can just use it, connect my systems and configure my stuff, and I can do all of that. But whereas when it comes to admin VDC, there are no ports in that admin VDC, I said. So when I say there are no ports in that admin VDC, can I use it for production? Absolutely not. Cannot be used in production. I cannot use this admin VDC. Okay, there are no interfaces in that. and I cannot use it for production. What is the purpose of this admin VDC? Huh? Only a couple of functions. This is used only to create other VDCs. It is used to activate certain feature sets. Okay. Everything you enable, everything you do in a Nexus has to be enabled through a feature set. So some of them you will have to do it only in the admin VDC. If you can enable in the admin VDC, then it will be activated in all the VDCs. And finally, if you want to upgrade the complete box, you can upgrade using this admin VDC. So basically, the management of administration of other VDCs is what I can do here. That's it. Now, because I use this only for that purpose, can I count that as one of the VDCs? Like if you take the default, I said, right? 4 you can have means 3 you can have, 1 is the default already there. 8 you totally can have means 7 plus this default is also there. So including the default, because I can use it in the production, I can count it. But if I am having an admin VDC, should I count that in the maximum VDCs I can have? No, I can't count, right? Because I can't use it for production. So that's why you see documents saying that 8 plus 1 or 4 plus 1. When you see that, that 1 is the admin VDC you can have. Okay, so if you have admin VDC, then you can still create 8 more VDCs. And similarly, if you have 4 plus 1, if you say admin VDC, you can still create 4 more VDCs. Okay, so that is what the admin VDC is used for. Use it for upgradation processes. If you upgrade it here, it will upgrade it on all the VDCs. If you enable the feature set on this, it will be enabled it on all the VDCs. And finally, you create the VDCs in the admin VDC itself. You can create, you can delete, and all that stuff.
Same we can do from the default VDC as well.
Use it to. Okay. If I say no to this admin VDC, then the place where I can do it is in the default VDC. And this is how we used to do it.
Mm-hmm.
Yeah. Even today, again, we used to do, today everybody is using admin VDC, but let us say you said no to it. In that case, you have to do it in the default only. Yeah.
And in default VDC, at least we will get the ports as well. But in
again, see, that is a miscellaneous thing. Na? Even though it looks like, okay, default VDC will have some ports. I mean, come on, you're not losing any number of VDCs, right? Admin VDC is a separate one. You still create 8 VDCs, right? Create one VDC, think of it like default in your mind if you want.
Okay.
No big deal, right?
And why we have limited till only maximum of 8 VDC? Is there?
Cisco wanted customers to be conjuice, not too conjuice.
Okay.
8 itself is a very big number, right? I mean,
okay.
Yeah. All right. See, the reason why I said, this is where I started, right? The reason why I said VDC is not something you would see in the production, no matter what fancily I call this, separate thing, separate nexus, separate, physically separated and all that, end of the day, I rely on these supervisor modules. End of the day, I rely on them. It's on a single physical box. People say, just for the sake of saying, we use this VDC for redundancy purpose. They say that. It's wrong. If, hypothetically, 2 supervisor modules go down, gone. Nobody can help us. You do not get redundancy. End of the day, it is creating separate memory spaces for each of the VDCs. It creates a separate context for them. That's why we call it virtual device context. in the memory CPU, it creates separate resources for them, separate OS copies, separate booting, separate control plane, everything separate. But end of the day, it's in the same physical memories and same physical CPUs. So in a production network where redundancy is really important, people don't use VDCs. People will buy two 7K switches. Physically, they are separate switches. That's what you see most of the time. Okay. Now again, we are not here to judge the client, right? Of course, maybe client is fine with it. They know the consequences of what happens if both the supervisor modules go down. They are okay. There are so many ports available. Instead of buying a 7K switch, they can buy two line cards. That is cheaper for them. Maybe, we don't know. Okay. But if you say redundancy is required, people don't use VDC. Simple. That's it. End of the day, because you still trust on these things, the common soups. So there is one more thing. We call that as HA, okay, high availability option. What happens is when you have one supervisor module, you can create a HA policy. What you can do is, if something goes wrong with your VDC, like Nexus VDC 1, something went wrong. Maybe your operating system crashed, something went wrong. You have a HA policy to restart, the HA policy for a single soup. You can restart. Restart means you can restart your operating system, Nexus OS, your VDC operating system. You can reload, which means you can reload the supervisor module, but keep this in mind, very dangerous. If you reload, because there's only one soup, right? A single soup module. If you reload that supervisor module because your VDC is having a problem, other VDCs will also have effect of it. Okay. End of the day, you are using the same CPU and memories. Very dangerous, but that's one option. And the other option you have is shutdown. So if you have a single supervisor module, and if you want to apply a policy, which you will generally do, like almost like a day zero thing, you have these three choices. The HA for dual supervisor module. If you have two supervisor modules, the system is going to detect it. And in that case, you have an option to restart your Nexus operating system. It tries to restart on its own if something crashes. Or you have shutdown, which means it will shut down your operating system, your VDC shutdown, and you can have switchover. You don't have an option to reload. What it does is your VDS is running on, for example, the supervisor 1, and that operating system went down for some reason. You immediately switch to soup 2. Okay, so those are the HA policies which you can apply if a failure occurs in that particular piece. So that's one thing which we will cover. Okay, and there is one last thing I wanted to tell you, which is kind of important. See, end of the day, I create a VDC so that I can give a separate physical separation, kind of physical separation. And then I wanted to allocate ports. Okay. I want to allocate ports. So the port allocation to the VDCs is dependent on the ASICs of the line cards. It is dependent on the ASICs of the line card. You have to see the line card model, product specs, or the port grouping, we call this. The port grouping. You will have to look into that line card's product specs to know what it is. Okay, why are you talking about? What is the significance of this? Here is the significance, which is important for you to know. See, I have this, let's say, I don't know, 48 ports, okay? 48 ports are there, 1, 2, 4, 5, 6, 7, 8, so on, 48 ports are there. Okay. Now, you cannot say, okay, port number 1, port number 1, port number 5, port number 7, port number 18 or 28, whatever. These ports I will put it into a VDC. You cannot say that. You just can't say that. Depending on the line card ASIC, which is, you can see it in the product spec, you can have individual ports in one single ASIC. You can have 2 ports, and that also, whether the 2 ports will be horizontal or whether the 2 ports will be vertical, that also changes. You have to see the product spec. It can be 4 ports and it can be 8 ports in one ASIC. It could be a single port, it could be 2 ports, that too it can be vertical or horizontal. It can be 4 ports or it can be 8 ports. I don't know. You have to look into the line card product spec for the port group. But what is important to know in this context is, if it is 4 ports, for example, and if you put any one of the ports in the VDC, all those ports in that port group will be in the VDC. You cannot separate them. So in a sense, in effect, you can put multiple port groups in different VDCs. Ports in the same port group, you cannot put them in separate VDCs. You can't do that. As a ASIC, you have to put it, not as an individual port. If you have a very good high-end model where every port has a separate ASIC, yes, then you can put anything anywhere you want. Okay, but that's not most of the cases. So keep it in mind. Tomorrow I may say, okay, 1/2, go to VDC number 1. When I go to the VDC 1, and when I say show IP interface brief or show interface brief, I will see ports 1/1, 1/2, 1/3, 1/4. I'm confused. I only put 1/1 in VDC 1. How come I'm seeing 4 ports? If you look at the background of it, this particular line card happens to have 4 ports in a single ASIC. If you put one of those ports in a VDC, all the ports in that ASIC will go into that VDC. Okay. So that's something to keep an eye on. Said that in real world, you will generally, even though there is one port available, even though 1 port, 1 ASIC is available, you don't randomly pick, right? It's not convenient for you. Sequentially, go some 8 ports, 16 ports, you generally put them in sequence. Generally supports the port group logic. Okay. But something you should keep in mind. Okay. All right. So with that, I want to end the VDC discussion. Okay. So we will take a break and come back, guys. We will come back by 11:20, 11:25. Yeah. And from there, I will move to VPC concept. Okay. So the plan is to finish EtherChannels and VPC today. Fabric path and OTV for tomorrow. And still there is 1 day. I mean, technically I have finished my content by tomorrow. Okay. We don't have to discuss VXLAN. We don't have to discuss ACI. But we want that to be discussed on the last day, Monday. Okay. So that's the plan. So we will finish VPC today, right? So 12:30 we'll be back, guys. Let's take 4 ports. if I say this is a 10 gig connection, the backplane, all these 4 ports are going to share that backplane 10 gig connectivity. They will share it actually. So even though it says 10 gig or 1 gig or whatever, the backplane is going to share, again, depending on the ASIC. It could be 4, it could be 2, it could be 8. I'm taking an example of 4. What I can do is, I can say, I don't want to share, rather I wanted to have dedicated port. By configuring a port as dedicated port, what happens behind the scenes is, the 4 ports that are sharing the bandwidth, they cannot do it anymore. It will be available only to that port, only one port. The backplane bandwidth for that ASIC will be completely dedicated to that one port. Here is a very important thing. If you configure dedicated, that bandwidth will be available only to the first port of that port group. I cannot say I will have it dedicated to this port or this port or this port. No. It will be available only to this port. Only to the first port in that port group. That's a very important thing you should know. Okay, I went inside this and said dedicated. It's not dedicated. No. It will be only dedicated to the first port. So you must have your connection, you must have your server connected to that first port, not to any of these ports. So this is a very important point. Second, now these 3 ports, they cannot be used. They cannot be used to connect to the systems. Nothing happens because there's no bandwidth there. Okay. And I will be pleasantly surprised if you can confirm, Bhotiraj, are your client using by any chance dedicated?
Yes, there were some ports was assigned to dedicated.
That is interesting, because I will be surprised, because it's not a regular thing to do. Why do you do that? Because I wanted this server to get that much of full capacity. Okay, because there is this too much traffic going in and out. So that is why you do this. But the trade-off is you are losing other ports. Okay, so it's not very common to do it. But again, as Bhotiraj was saying, maybe Sun client, they were using some ports. Yeah, they can. Okay. All right.
So in dedicated mode, all the throughput would be dedicated for a single server, like
single server.
Yes. But in share mode, at least we can utilize for others.
Yeah. Very important concern would be port density is lost. Huh? If I do that for an 8-port ASIC, and if it is 32 port total chassis, 32 ports, how many ports are you going to use with dedicated?
A single one.
4 ports, right? Each ASIC is 8 ports. So 32 ports means there are 8 ASICs.
8, okay, 4 ports, right.
First port of that 8 ASICs, one port group I'll use. 4 ports I'm using. Remaining all ports are wasted. Okay, that would be an important concern. But again, yeah, it's all commercials, right? So maybe you already have the switch, you are sharing it with other customers, other clients. They wanted some dedicated. Yeah, they can. And if they are very rich also, they can use it. So again, the requirement is this. What happens is what you know now. Yeah. When you want to use it, left to the requirement. All right. Okay, with that said, I would like to divert our attention to ether channels.
So Kalyan, in 9K, is there any VDC concept or only it is limited till 7K?
Only the 7Ks. VDC, I don't think we have it, but again, 9Ks are evolving pretty fast. Okay, very recently, like 2 years back, 9K was not supporting storage. Now 9K is supporting storage. Okay, so look into the latest documentation for whether VDC is supported or not. But on top of my head, if you ask me right now, no. Okay.
Okay.
Kalyan, what is MDS in Nexus switches?
What about it?
MDS.
MDS is a storage switch. MDS is the Cisco's flagship storage switches. Just like Brocade, just like HP storage. Cisco has MDS switches. Anytime you connect your storage network, you connect it to the MDS switches. Okay.
Means we do not need to external extra switches for storage.
I mean, because that extra switch is an MDS switch, you don't need anything else.
Okay, I think Nexus 9K is a MDS switch.
No.
Am I correct?
No, you should not say that. That is a wrong way of saying it.
Means few models.
No, that is a wrong way of saying it. But
You can say it's like a university.
Let me tell you why you said that. It is not just 9K, 5Ks and 9Ks nowadays. Both of them have unified ports, which means they can directly connect. They can be converted into FC ports and they can be directly connected to the sandboxes. It could be your SAN arrays like targets, or it could be your HBA cards. You can do that, not only with 9K. 9K, that's what I was telling you, right? Initially, 9Ks were not supporting storage. Last 2 years, they started supporting storage. But 5K, from the beginning, it was supporting storage. So you can, quote unquote, tell, if I have a 5K, I don't need an MDS. You can say that. But that's not the way you look at it, okay? I can have 5K converted into storage switch, part of it, and part of it can be left out as Ethernet switch. So, because those are unified ports and I can use them one at a time, okay? I cannot use the same port for FC and Ethernet at the same time, but I can use them either that way or this way. So if I have a very small setup, like only 3 storage boxes and 10, 20 HBA cards on the server side, yeah, I don't need to have a storage switch. My 5Ks will help me out. If I have a 9K, 9K will also help me out. So in that direction, maybe you have heard or seen somewhere people saying, if you have a 5K or a 9K, you don't need an MDS switch because I can use the ports. I can treat it like a storage switch. Okay. But in production, in reality, I mean, storage network is a separate network. Okay. Here and there, you can merge with 5Ks, but most part, it will be a separate thing. One thing a little interesting to us is these MDS storage switches, they used to run Nexus operating system from the beginning. Like they used to have a majority flavor of NXOS. So Cisco, they built on top of that. They built on top of the storage operating system. They built the NXOS and started putting it in the Nexus line of products. So that's another interesting fact.
And one more thing, Kalyan, and fiber channels are just only to connect the SAN devices to the Nexus switches.
Repeat the statement. Fiber channel and fiber channel over the Ethernets are used just to connect SAN boxes, storage devices, we can say. Yes. FCOE is completely a different logic. FC, yes.
Mm-hmm.
FCOE, I can do
Okay.
it with Ethernet also. No problem. All right. So let us get to the ether channels.
One more thing, Kalyan, in Nexus, is there any limitation? I mean, for number of VRF creations, in 5K we have only two VRF. We can, I mean, by default VRF and management VRF. So in 7K, 9K, also the same thing.
There is no limitation on the number of VRFs. Okay. I don't see any practical limitation on the number of VRFs you can create. Okay. Let it be 5K or the 7K. Now, if you are saying default, I will have two VRFs, management and the regular normal global VRF, default VRF we call it. Yes, default, that's how it is. Let it be in the 5K or the 7K, the same thing.
Okay.
All righty. So, ether channels, why do I need it? Simple. In order to, no. In order to have higher bandwidth capacities. In order to have higher bandwidth capacities is where and why I would need ether channels. Try to stop using the word ether channel and start using the word port channels. Get used to this. Both are the same. Most of the old school, we used to call it ether channels, but now we are getting away from that term and just trying to stick to the word port channel. Okay. Unfortunately, some of the enterprise switches still call the command show ether channel summary, so we are still stuck with this term. But if you go for Nexus, we don't call it show ether channel, we simply call it show port channel summary. So get used to this word. So when you said port channel is used for redundancy, I said no. Okay. The reason why I said no is STP is there, na? STP is there to take care of redundancy. Why do I need a port channel for redundancy? No, that's not the reason. I use this for higher bandwidth requirement. I don't want to even say for better utilization of the links. Parallelly, I am able to use the links, right? I don't want to even say that. Why? Because we discussed that in PVSTP, wherein I can have a switch with two connections, but for VLAN 10, I can use the top link. For VLAN 20, I can use the bottom link. I can do that. So thereby, I can I can use multiple links simultaneously with redundancy. If this link goes down, then all the VLANs will go in the top link. I can use that. I can make use of that, and I can use multiple links simultaneously. If I wanted to minimize the number of instances, I will use MSTP. So if I simply wanted redundancy, my STP will just do things. If I wanted to have parallelly using multiple links, I can run MSTP instances or PVSTP instances I can use. But the problem with all those solutions is for that one VLAN or for that MSTP instance, either ways, only that one link can be used. And that one link has an upper capacity, 10 gig, 25 gig, 40 gig, whatever. The primary reason why I would like to go for an ether channel is the demand for more bandwidth on a per VLAN basis. That is the reason why I would go for ether channel. Yes, sure, I would get load balancing. Yes, sure, I will get redundancy there also. Yes, sure. I can use parallelly all the links. Sure. I get all the solutions that MSTP or PVSTP is providing, plus higher bandwidth. So higher bandwidth is the real differentiator for using ether channels versus any other solution which we discussed before. Okay. How do you configure it? I don't know. Should I even talk about it? I'm already making an assumption that you all know about it already. Simple. You go to each of these physical interfaces, 25, 26, 27, 28. You simply go and put them in a logical interface called the port channel. Port channel 1, port channel 1. Should the number be the same? No, not required. But almost always we will have the same number, so that easy to identify. Once I put these physical interfaces in this logical port channel, and once I create the port channel, what happens is, from STP's perspective, which is the control plane, when I say STP, it could be MSTP, RSTP, whatever, okay? So from STP's perspective, this looks like a single interface. It does not look into 4 physical interfaces. It does not see it as 4 interfaces. It's just one interface. Now, because it sees it as a one single interface, according to my root port designated port selections, for example, if this is the root switch, I will make this port channel a designated port, and the corresponding port channel on the other side will become a root port. So from an STP's perspective, it is simply one port channel. And I simply brought that one link up, put it in the forwarding state. Second, from a data plane perspective, when a frame is coming from 10.6 trying to communicate to 10.5 or maybe 10.5 to 10.6, whatever, when the frame comes here, it will be sent to all the ports in that VLAN, and along with that, it will also send it to the trunk port. Now, this time it is sending it to port channel 1. So, not only the control plane protocol STP, even the data plane protocol, data plane traffic, it will also be sent to the port channel, not to the physical port. And thereby, I am not treating them as 4 links. Let it be in the control plane level or let it be in the data plane level. So with this, okay, your data is coming to this port channel, you said, fine. STP is thinking of this as a port channel, one link, one port, and bringing it up. But end of the day, I see 4 physical ports, right? 4 physical ports are there. How will the data flow happen? How will the data flow happen? When the data comes to the port channel, as far as the switch is concerned, it is sending it to all the ports. Along with that, it is also sending it to the port channel interface. But once it reaches the port channel interface, how will the packets be physically sent on the wire? This is where you can decide how to load balance. This is where you decide how to do the load balancing. Okay. Now, first thing I have to be clear. The packet or the frame will not be sent on all the ports. If that is sent, then the loop is created. Right? So it won't be sent on all the ports. It will be load balanced. Now, how do I load balance? I don't know. Depending on the model, depending on the version, depending on the platform, your load balancing capabilities will change. And the default load balancing method will also change. I cannot give you one answer. But I can give you all the possible options you have. You can do it based on the source MAC, based on the destination MAC. You can do it based on the source and destination MAC. You can do it based on the source and destination MAC and IP. You can also do it based on the source and destination MAC, IP, and port number. The more you can take for the load balancing, the more criteria you can take for load balancing, the better load balancing you can get. Okay. Default of it, I don't know. Depending on the platform, you will have to find out. But almost always, whenever possible, like in the production environment, take the maximum capacity. Like maximum how many criteria can be taken, use that. That's a general rule of thumb because you get better load balancing. If you do this, the very last one, you are basically load balancing on a per flow basis. Okay. Just as a side note, which kind of from a design perspective, it is important. What it does is internally, it will take the criteria and do its crazy mathematical equations, and it will create a hash. Okay. And the hash value will be one of the port, like if the 4 ports are there, hash value can be between 1, 2, 3, 4. If there are 2 ports, hash value can be between 1 and 2, like 8 ports, 1 to 8. So it will generate a hash. It will generate a hash, and the hash is generated based on this criteria, whatever criteria you select. And based on that resulting hash number, it will use that particular link. I mean, we don't have to dive into these mathematical formulas and all. We don't need it. But what I want to highlight here is even number of links is always better for good load balancing. Okay, keep that in mind. Can I connect 3 links? Yes, you can connect. Can I connect 5 links? Yes, you can connect 5 links. But when you do that, like internal mathematical logic, if you have odd number of links, going with a proper load balancing will not happen, even though you take this like highest granularity. So that's why we do it. And that's why when you see documentations, you will see that 2, 4, 6, 8, right? It's not like 3 cannot be used. We can use, but generally, good load balance doesn't happen. So keep that in mind from a design perspective. Try to keep even number of links. Okay. So in order to configure the port channel, you simply say interface range, whatever fastest and 0/24 to 28. Okay. So what is that? Channel group number, which is the port channel number. Okay. And we will talk about this mode on or active, blah, blah, blah. Oh, but this is the, and then you create this number, right? So that will become, let's say channel group number 1 you gave, or maybe, 1 you gave. So then it becomes port channel 1. Any configuration you want to do, you will do it here. Okay, that is recommended. Now, in enterprise networks like the regular iOS, you can still go into the LAN interface, like the physical interface, and you can still do the settings. Not recommended at all, but still you can do it. But in the Nexus line of products, they made it a very strict rule. Once you put the interfaces in the port channel using this command, you cannot do pretty much a lot of config in the physical interface. You can't even do it. Cisco restricted that. It is already in the port channel. Go to the port channel and do it. But in the iOS, still you can do it in the physical port, but again, not recommended to do it. Okay, so that's a subtle difference between the enterprise configuration and the Nexus configuration. Okay. So, point I want to derive here is configuring a port channel is very simple. mentioning the load balancing algorithm is simple, but the true challenge is, this is where a lot of fuss is there. The configuration which you do on these devices, the settings on these devices, they must be exactly the same. Identical configuration should be there on both these parallel ports. It must be there. Okay. Now, people ask the question, okay, is it between these two ports or between the ports of the same switch? Technically, it is between the two ports. Okay, so which means if this is 10 gig, should be 10 gig. This can be 1 gig, but then this should be 1 gig. So technically, it is on the opposite ports that the identical setting should be there. But practically speaking, to get real about these stuff, all of these will be same and all of these will be same. Okay. You don't configure one port as trunk port, one port as an access port. You don't do that. You don't have one 10 gig, one 1 gig. You don't do that. So technically, opposite sides should be the same. Same setting should be there. Practically, basically, all these 8 ports will be the same. They must be having the identical settings. Okay. Now, what are those settings? I don't know. I don't know. I can give you some of those settings. Duplexity, for example. Speed, for example. If you configure them as access ports, they must be in the same VLAN. If you configure the trunk port, allowed VLAN should be the same, native VLAN should be the same. Yesterday, I think we discussed about the native VLAN. If it is mismatched, no big deal. Communication will happen. Yes, communication will happen. But if you want that same ports to be in a port channel, then on both the sides, they must have the same native VLAN. Otherwise, that port will not be in the port channel. Okay. So these are all the basic settings that have to be the same on both the sides. Okay. Now, one interesting thing, because there is a lot of hype on this thing, right? Everything has to be the same on both the sides. There is one exception. The load balancing I do, they don't have to be same. They just don't have to be the same on both the sides. On this side, I can do load balancing based on all the 4 criteria. And on this side, I can do load balancing based on maybe only 2 criteria or maybe these 3 criteria, whatever. So the load balancing doesn't have to be same. Said that, generally it will be the same. But it's not a rule. But the other port settings, like the duplexity, speed, or access VLAN, the same VLAN, trunk, same allowed VLAN list, and the native VLAN, all of that has to be the same. This is where everybody recommends, Cisco included, recommends use a protocol. Use some protocol that can look into these details. And if there is something wrong, it will give me a message, log message or whatever. It tells me that there is a mismatch on so-and-so thing. So when you are creating a port channel, use the protocol. And there were 2 protocols. One is LACP, Link Aggregation Control Protocol, and the other one is PAGP, okay, Port Aggregation Protocol. PAGP is a Cisco proprietary and rest in peace. It's not used anymore. When it comes to the Nexus line of products, it's not even a choice. Over, it's gone. So today it's everything LACP, Link Aggregation Control Protocol. This is the one which is used basically to check these variables, whether all the variables on the other side, settings on the other side and this side are same. If they are a mismatch, it throws an error. And if they are not mismatching, that means if they are all same, then it will create a successful port channel. Okay. So whenever possible, use LACP. So here we have certain modes for LACP. You have active and then you have passive. When you configure the mode of LACP as active, it will initiate a port channel and also accept. But when it is passive, it will only accept the port channel request. Now, there is no reason why you should use passive. No reason. Okay. Whenever possible, use active. So this is where I want to complete the command. So channel group number, whatever number you want to give, you give that. And then you say mode. Here you have active, which is going to activate LACP. You can say passive, which is also going to activate LACP. But then passive, don't use it, just use active. Because both will be now actively trying to form a connection. There are other modes like desirable and auto, which is used for PAGP. Desirable is like active, which will initiate and accept the trunk request. Auto is like passive, which is going to which is going to accept the trunk request but not initiate. So if you give any of these modes, PAGP will be activated. If you give any of these modes, LACP is activated. So whenever possible in real world, try to use this. But there are cases where protocol is not running on the other side. In that case, use on. Not recommended, but no choice. What if I have a system connected to a server which I want to bundle in a single port channel? So here I will do NIC teaming. I'll just put them in a single port channel on a server side with the operating system. So on my switch side, there's no LACP running here. If there's no LACP running here, then I have to put this as on. So in a case like this, yes, go for mode on. But otherwise, just try to use LACP active. Again, the main reason is I can check the variables dynamically. The protocol will check it. And if there is a mistake, mismatch, it will immediately tell me. Okay. Now, here is the thing. So when you enable LACP, automatically the port channels will be created if all the settings are same. That's what I said. But how exactly will that happen? Let us say there are these two switches, okay, connecting to another switch here. So let us say I have connections like this and then connection like this and then connection like this. Port 1 and 2, 3 and 4, maybe, 1 and here I have, 5, 6, 7, 8, 9, 10. How does the switch 3 know which ports I should put it in a port channel? How does I know? How do I know? Maybe I'll put this in a port channel. Should I put it? Maybe I should put this in a port channel. Or maybe I should have these as separate port channels. How does it know? How do those switches know? How does the LACP know, to be very specific, that this is one port channel, this is another port channel, this is another port channel going to another switch. How will it know? And for that, you need to understand what is called as lag ID, link aggregation group ID. Now, this is a combination of two things, okay? You have what is called as a system ID, and then you have what is called the group ID. Both together is called lag ID. Okay. System ID, it's almost like a bridge ID, okay? Your system ID is again a combination of, your system priority and then the system's MAC address. Almost like a bridge ID, right? Instead of calling it as a bridge ID, we simply call it as a system ID now. So within LACP also, I can have this priority set if you want. Why I doing to set a priority? I'll tell you that, but this is the system ID. So now what happens when the LACP information is coming? Each switch is going to have their own unique system ID, right? Even though the priorities are same, the MAC address will break the tie. So with that, I will get the first piece of information. Switch 3 will get the first piece of information. Oh, 5, 6, 7, 8 are connected to switch 1, 9 and 10 are connected to switch 2. Because I am getting a separate, different system ID. Because of that, I know this is not a port channel. I can't do this. They are separate switches. Next, okay, 5, 6, 7, 8, they are all coming from the same switch, right? So switch system ID is the same. Now, how do I know this is in a port channel and this is in a separate port channel? How do I know that? And that is where the group ID comes into picture. The group ID is nothing but the value which you give here. Channel group number you give, right? For these two ports, if you want to put it in the same port channel, you will give the same group ID, right? Based on that group ID, I will know, oh, okay, so the other switch is trying to form a port channel with these two ports. Now we start checking the variables. Are the parameters same or not? They are same, then the port channel will be formed. So all of this together is what we call lag ID. Are we clear with this? Yep.
Yeah.
All right. Any questions up till this point?
So Kalyan, is there any election like master or slave?
Nothing like that at this point. I will tell you what the priority is used for. Okay. So for the port channel creations, I need to first figure out, am I connected to the same switch or not? That is decided based on the system ID. Second, if I'm connected to the same system, meaning the same switch, which ports have to be in a port channel? For that, group ID is used to identify them. Okay. Now, I told you that we will discuss about why we need the system priority. Here is the thing. When it comes to LACP, the feature or the speciality of LACP is you can have up to 16. You can have up to 16 ports, 16 links connected in a port channel. Okay. For PAC-P, it is only 8. For LACP, you can have up to 16. Now, very important to understand. You can have up to 16 links connected, but only 8 active at a time. You can only have 8 active. Whoa. If only 8 can be active, then why will I connect 16? Again, what is the purpose of LACP, I said? What is the purpose of EtherChannel, I said? Bandwidth, not redundancy and all. Yes, they will come. Side effect, they will come. But the primary reason is bandwidth. I need more bandwidth. So if I have 8 connections, and if one of them goes down, I mean, 10% of the bandwidth, like 1/8 of the bandwidth is gone, right? So I don't want that. I want, if one goes down, I should still have the next one, so that I can always have 8. So you can have 16 connections, but you will have only 8 active. Okay, obvious question, right? Which 8 will be active? Which of those 8 will be active? Now the answer is this. First of all, there are these 2 switches, right? The connection, the links are between the 2 switches. First of all, they have to decide who will take the decision. Okay. Should I take the decision? What decision? The decision of which 8 ports. The decision of which 8 ports are going to be active. So, will I take the decision or will you take the decision? That is dictated by the system priority. Lesser the better, okay? So if this switch has got priority of 5, MAC address is 9, this has got a priority of 7, MAC address of 8, whatever. Because this has got a better system ID, lesser priority is better, switch 1 will decide which 8 ports will be active. So that's the first decision to make. Okay, connections are made both sides. Will I take a decision or will you take? Okay, now switch 1 is the one taking the decision. For example, just to prove the point, if this is like what priority is 5, MAC address is 8, then in that case priority is the same, MAC address is less for S2, so S2 will take the decision. Okay. I don't see any document saying, I mean, maybe I don't remember them, saying master slave, nothing like that. Okay. But definitely there is one who is taking the decision on which 8 ports to be up. Okay. Now, in this example, let us say S1 is taking the decision. Okay. Out of these 16 ports, which ports I should take? This is dependent on port priority and the port number. Almost like a port ID, right? In a ST. So each port I can set a priority. For each port I can set a priority. So lesser the better. So the first 8 I will take. If the port priorities are all same, then based on the port number, I will take the first 8. It is worth knowing this point. But if I get real about it, I don't care, right? Because all of them are going to be same bandwidth capacities. So I don't really care which links are up. Because they are having the same bandwidth capacities, I don't want to set any priority. Okay, and there's no need. I mean, if bandwidths are different, then maybe I will use higher bandwidth. I will give better priorities. But generally, the bandwidths will all be same for all the ports. So I don't really care. In production, the first 8 numbers, okay, those will be active. The others are just there. Okay, so it is worth knowing that there is this mechanism of up to 16 connections you can have, and you should know how the decision process is made. But then in reality, The first 8 ports will be up. That's it. Yeah. Any questions, please?
Kalyan, is there any difference? Is there any difference ether channel between switch to switch and switch to fax?
No difference.
Because I have seen means when we create a port channel between the parent switch and the fax, we just create a group channel and the number only. Means we do not select any active or passive.
Why is
What
that
is
so?
please elaborate
Why
this.
is that so? Nothing?
Yeah.
There's nothing to elaborate on this. What you are going to do on this side, when you have a server which is not capable of running any control protocol, you make it on, right?
Yes.
That is exactly what is happening.
So it means that a fax doesn't have the facility, means LSEP active or passive. That is why.
Yes. Fact of the matter, there is no control protocol, there is no data plane transmission on the faxes.
Oh, that is why we.
The parent and come back.
Okay, so that is why we just create a group channel and then number the channel number.
Yes.
Okay. Thank you.
All right. Okay, so that's it. Now, what's the problem with this? We talked about LACP. We wanted to have a port channel, which is good. What else do we need? The problem with this is still you are getting extra bandwidth, no doubts about that. You are still getting extra bandwidth. But if this device goes down, for example, switch 1 to switch 2, if this device itself goes down, then I don't have a means of going out. Okay. This is where we wanted bandwidth, link redundancy, which is already coming with the port channels. But now I also wanted device redundancy. So how do you achieve that? This is where they came up with the concept of multi-chassis Ethernet. This is not a technology coming now in Nexus. We used to have it in catalyst switches. We called it as VSS. But in Nexus line, we have VPC. The idea behind that is this. You will have physically 2 switches available, connecting to a downstream 3rd switch. I want to have 4 connections. That means I wanted to get 40 gig, for example. But however, when I do the port channel, I should do a port channel with all the 40 gig. However, I should not be just connecting to 1 switch, but I will be connecting to 2 switches. Why? Because if 1 switch goes down, I can still have another switch. Device redundancy is what I can still get. I have no compromise in the bandwidth. I want 40 gig, I'm getting the 40 gig. Link redundancy is there, which is anyway there in the port channel. So I get my bandwidth, I get my link redundancy, and now I also get my device redundancy. This concept of having a pair of switches connecting to a downstream switch is what we call VPC. The fundamental idea idea is this, the fundamental goal. How it is achieved, we will discuss that. But the fundamental goal is this. For the downstream switch, the two switches here, they should look like a single virtual switch. It should look and feel like a single device. Because lag P, remember that's the same process, lag P is running. If I see that as two different switches, I don't form a port channel. This port channel will not be formed. If I think of them as, if I realize that these two are separate switches, on my side, I won't form a port channel. So I need to somehow give that illusion that the two switches are acting like a single switch. So how do you achieve that? So you need to understand what a VPC, you need to understand how a VPC works. What a VPC does, over. I already talked to you about it, that's it. It will simply create a port channel, creating the illusion of a pair of switches acting like a single switch. So now the question is, how will it work? So in order to answer that question, we need to understand certain terminologies, okay? First of all, the two switches that you're connecting, and making it look like a single switch, this is called as a VPC domain. And this is identified with a domain ID, almost like a group ID. Now I will define these two switches in a single domain. Okay, that's the first thing I have to do. Here is a very important point to understand. Can I have more number of switches? Like more than two, can I have? Okay. Can I have more than two switches in a single VPC domain?
No.
No, you cannot have. Only two switches. Okay. Can I have another switch and then I can put this switch in two domains? In this domain, I will have S1, S2. In this domain, I'll have S2, S3. And the answer is no, I cannot have. One switch in one VPC domain. You cannot put it in two different VPC domains. Okay, so very important limitation. And the third, which is really important for production, they should be of same make. Not same model, but same make. Okay, and this is Nexus technology. VPC is used in Nexus. So I will have a 5K here and another 7K here. Can I do VPC domain? No, you can't do it. 5,000 and 5,500? No, you can't do it. 7,000, 700? No, you can't do it. Okay, 5532, 5548? Yes, you can do this. They don't have to be the same model, but they have to be the same make. Okay, that is important. So tomorrow, if you want to do VPC, I have a 5K in my rack, I have a 7K, they are just sitting there ideally. I want to put them together. No, you can't. Okay, so these are some of the restrictions which you have. You can have only two in a VPC domain, one switch in one single domain, you cannot put it in other domains. And then finally, they should be in the same make. They can be of a different model though, but they should be on the same make. Okay. Now, some people ask, should the version be the same? It's not a thumb rule. It's not a rule like it should be same. But at the same time, I cannot have a 4.3 version and then a 7.3 version and then make them work. Okay. So there is a little bit of compatibility you will have to check. But most part in production network, you tend to have the same version. Okay. So technically not a rule that you should have the same version, but at the same time, it does not mean any version is compatible to anything. Safe to say n-2, I think it should be fine. Okay. But anything less than that, you'll have to look into the compatibility guide. Okay. Said that most of the time they will be of the same version. Right. So that's the thing about VPC domain. So I need to first create this. Okay. The next thing I have to do is, okay, I have created the VPC domain, but then they should know that, right? These two switches should know each other. And there is a lot of things that are going to happen. Data is going to come to these switches and they should know how to interact. They should know. There's a lot of other stuff which I still did not discover. There's a lot of things. What will happen when the data packets are coming? I need to synchronize the MAC address tables. Don't worry if you don't understand what I said. We will talk about it. But the fundamental point is these two should know about each other. Okay, I have another peer. I need to know that. So for that, you need to understand another term. You need to configure what is called as a peer link. You need to configure a peer link. Now, this peer link must be a port channel and must be a direct connection. I cannot have a middle switch something and I cannot connect them like from the middle of the switches. They must be back-to-back connected. And it must be a port channel. But only one wire I want to connect, only one cable I want to connect. Even if you want to connect one cable between the switch to switch, you still have to create a port channel and you still have to put it in a port channel, that one wire. If you don't do that, that peer link won't come up. So you need this peer link. Now, why do I need a peer link? The peer link is used to first discover the peers. Okay. First, I should know, right? Switch 1 should know switch 2 is a part of my domain. Switch 2 should know switch 1 is part of the domain. They both are peers. We call them as VPC peers. Okay. So VPC peers. So they should know each other. First, they should discover each other. And the second and the major function is for database synchronization. And check, very important to understand this, check the config sync. I don't know, I don't want to use the word config sync because there is a concept of config sync in Nexus. Yeah, I'll keep it simple. Check configuration parameters. It is used for database synchronizations. Now, when I say database synchronizations, there are two major database synchronizations that should be done. One is the MAC address tables, and the other one is the IGMP databases. Okay, this is for multicasting purposes. Okay, and if it is acting like a gateway, the ARP tables are also to be synchronized. So the databases are to be synchronized. Okay, where exactly will this apply? We will come to know about it. We will come to know about it when I talk about the data flows. Okay. When I talk about the data patterns, I will tell you what this synchronization is really about. But there is a third function, and that is checking the configuration parameters. See, when I wanted to configure a VPC, first of all, when I wanted to configure a regular port channel, right? When I configure a regular port channel, okay, I will put that there. See, when I want to configure a regular port channel, for example, from this switch to another switch here, all these ports, all these interfaces, they should have the same setting that matches with this, right? They must be the same. Whatever configuration you have on this, they must also match. But now what is happening? Okay, first of all, this is easy for this switch because the ports are local ports. I know it. But now what is happening? There are two separate switches, switch 1 and switch 2. 2 ports from here I am taking, 2 ports from here I am taking. So I need to make sure these port settings are same. And because we are participating as a single switch, we are trying to act like a single switch. Our global settings have to be same. For example, if I am running RSTP and here if you are running MSTP, then that's a problem, right? If I have certain VLANs created and if you did not create VLANs, then that is a problem. The fundamental difference with this VPC technology is the control plane and the management plane are separated. This is one of the key problems, I would say, but Cisco says this is one of the key features of VPC. So I cannot go to one console and configure these two devices. I cannot do that. They are separate boxes. STP is running separately. If you run OSPF, that is running separately. If you want to telnet into the box and configure something, that's a separate management port. Everything is separated. But now they both should think and act like the same box for VPC purposes. So I need to make sure that the configurations on these sites are properly matching. Let it be the global configurations, let it be those interface configurations. I need to make sure they are in sync with each other. If any of them is wrong, misconfigured, I'll have to update. I'll have to create a log. I have to inform the administrator that something is wrong. And for that, I use this peer link. So it's not to synchronize. That means if there is a mistake here, automatically something will override the other. No, nothing of that will happen. It won't sync. It simply checks the parameters and it is going to tell if there is any inconsistency in the configuration. So that is the purpose of the peer link, and it's a very important link. Okay. Next, you have what is called as, this is how we draw the diagrams. We have what is called as peer keep alive link. I feel a little sorry about this link actually. Why I feel a little sorry, later you will come to know. But the point is, this keep alive link is used to check whether the peer is up or not. Okay. What do you mean whether the peer is up or not? I'm using the peer link, right? I'm using the peer link to discover my VPC peers. Then why do you need this? This is required when you have failure. Again, we're going to discuss all failure scenarios. So we'll talk about that. But understand for now, the peer keep alive it checks the availability of the peer through basic pings. Okay, we call it keep alive, just like a keep alive packet in a regular interface, just like an hello packet in OSPF or EIGRP. This is used to check whether the peer is up or not. This is a backup mechanism. It's a backup mechanism to check whether it is there or not. Internally, the logic is it will send pings. Okay. Now, interestingly, some people call it, which is appropriate to say, they call it as UDP pings, not ICMP pings. Huh? They call it UDP pings. It's almost like, almost like a keep alive packet, like hello packet. You just send and get the responses back. So it is used to check the availability of the peer link. Okay. Initially, this keep alive is used to bring the VPC domain up. Later, it is used to avoid the split brain scenario. It is used to avoid the split brain scenario. Now, both of them, initially the keep alive is used to bring the VPC domain up. Later, it is used to avoid the split brain scenario. Both of them right now may not make that much of a sense, but stick on to this. Stick on to this. We will talk about it. Okay. But for now, understand, you need to have a backup link through which they send pings to each other and check the availability. And the way they do that is using any layer 3 interface. So there will be an IP address to this, 1.5 for example, there must be an IP address to this, 1.7 for example, and you start giving the keep alive link. For S1, you will say 1.7 is the keep alive destination, 1.5 is the source, and similarly for S2, you will say 1.5 is the destination, 1.7 is the source. Okay, you will use this keep alive link to check each other's availability. So for now, keep that in mind. And for me, it was a little surprising. I thought VPC is already there. There is a VPC domain, there is a peer link, there is a keep alive link. So VPC is ready? No. The actual VPC is this. This is the VPC. I thought this is the VPC, but really no, this is the VPC. This on the VPC domain side, these ports are virtual port channel. As far as your downstream device is concerned, for them it is just a port channel. For them, it is just like connecting to a single switch. So what you see here on the two switches side, that is the VPC. Okay, this guys, these ports. And these ports that are connected to the VPC, they are called as VPC member ports. They are called as VPC member ports. Okay. All right.
So means to say that any one of the port will be the active one and other port will be the members.
Wrong. Answer, please. Logically, this is your setup. This is the port channel. Now this is the VPC. Which of these ports is active in this setup here? Answer, please. All. So which of these ports are active? All the member ports are active. Unless, of course, there's a physical connection issue. Huh? This is the port channel. Logically, this is like a single switch, S12. Each of these individual ports, we call them member ports. That's it. Which member port is active? Everybody is active. Are we clear? Yeah?
Yes.
Yeah. And the last thing, you may have certain systems which are not connected in the VPC fashion. You may not connect like this. If you don't connect like this, then these ports which are not connected in the VPC fashion, these ports are called as orphan ports. Single homed. I did not connect it to, even though I connected to the VPC domain, I did not connect it in the VPC fashion. I did not connect like this. So if I did not connect, then this is a orphan port. Similarly, if I have, again, a server connected to this port and I connected to this port, but it is active standby. If I connect like this, that means there is no port channel here. I did not configure any port channel. It's just active standby, just need teaming, active standby. If this is the case, then also this is an orphan port. Okay. So if you connect physically one or logically one at a time, in any of the cases, it's an orphan port. Only when you want to connect them like this in a VPC and all of them are active, like a proper virtual port channel, then they are member ports. Otherwise, they are orphan ports. Are we clear? Okay. So we just defined the terminology. The VPC domain terminology is what we have defined. But we have a lot others to discuss. Okay, how will it come up? What is the data flow? What happens when the data is going into this switch, coming back here? What is the loop avoidance logic? What are the failure scenarios? So we need to discuss all of those things. Okay.
Hello.
Yeah.
So the last term is
Need a break.
Yeah. 1 minute. The active standby is there. I was connected to active standby. If in the scenario I want to audit the servers which are active, connected like this, what is the command I have to check? Basically, how to check the orphan ports information?
How to check orphan ports?
Yeah.
Yeah, we have a command, show VPC orphan ports. By looking at that, you can check it. However, there is a small catch to that. If that port, for example, this port is having a VLAN number 10, for example. If that VLAN is allowed on the peer link, then with the command show VPC orphan ports, I can check it. But if that port, that VLAN is not allowed on the peer link, then there is no way I can find out. That command will not give me any output. Okay. generally speaking, assuming that the VLAN is allowed, then the command will work for you. Okay. Otherwise, you have to manually find out, looking at the document or physical setup, which port is not connected in the VPC fashion. Accordingly, you can find out.
This is applicable to 5K also. 5K.
Yes. This is VPC applicable to 5K, 7K, and 9K as well now. Okay. Yes, guys. So we will take a break. We will come back. And once we come back, we will talk about this, the details of VPC. Okay. So if you don't mind, can you guys come back by 2:30? So initial VPC bring up. Now this is what happens when you power on, when you configure the VPC peer link, when you configure the VPC keep alive, and hopefully configure your VPCs. This is what you expect to see as a bring up process. The first thing that happens is the VPC peers check the availability of each other through the keep alive link. So first they will check the availability of each other through the keep alive. Okay, so you have configured this keep alive on the switch 1, switch 2, you configure 1.2. 2 as the neighbor on switch 1, and you configure 1.1 as the neighbor on switch 2. So they first check whether the keep alive is there or not, whether the neighbor is reachable through the keep alive or not. So then they check whether the VPC peers, they will check the peer link status. So then what they do is whether the peer link is configured with port channel, whether the link is up or not is what they will check. Now, once the peer link check is done, once they check that the peer link is up and active, then what they do is the peers check the configuration consistency using a protocol called CFS. Now, this is again a protocol from the storage, actually, Cisco Fabric Services. This is the protocol which was used for a lot of things in CFS. A lot of things in storage. So here they brought the same protocol, but rather here what it does is it will check the configurations on this side and this side. Remember I told you for VPC, the management is separate. So you have to separately configure them. The control plane is separate. They are running separate STP, separate RSTP, separate OSPFs, anything that you run. They are all separate. So the CFS protocol is checking the connectivity, configuration on both the sides. So here, there are two types of possible consistency problems. They call them as type 1 inconsistency and then type 2 inconsistency. Now, within again type 1, there is global and there is interface. Within type 2 again, there is global inconsistencies and interface inconsistency. Now, here is the thing you should understand. If there is a type 1 global inconsistency, the VPC domain is not brought up. Like nothing in the VPC works. The VPC domain will not come up. Now, as an example, if your STP mode is different on both the sides, one side is running RSTP, the other side is running MSTP, then the VPC doesn't come up. There is a very nice command, show VPC inconsistency. You can see all the list of inconsistencies that are on a particular switch. As a matter of fact, it gives me a comparison table. On the switch 1, this is what is configured. On switch 2, this is what is configured. So it will give you a list of what is configured, and very easily you can identify where is the mismatch. So that is what CFS really does. It just checks the configurations. So if there is a global type 1 global inconsistency, the VPC domain itself will not come up. Okay. If you have a global interface inconsistency, in that case, the VPC will not come up. So VPC domain, if it doesn't come up, then all the VPCs won't come. None of the VPCs will come. But if there is an interface problem, so maybe this interface and this interface is having a type 1 inconsistency, interface inconsistency, then that VPC will not come. The other VPCs will come, no problem. As an example, interface inconsistency type 1 would be something like one is configured as an access port, the other is configured as a trunk port, then it's a problem. Okay, so that is the type 1 inconsistency. As a general rule, the type 1 inconsistency is going to have a big impact. Global problem, then the VPC will not come up. Interface inconsistency, then the VPC itself will not come up. But if you have a type 2 inconsistency, it's not going to be that rude. If you have a type 2 global inconsistency, you are going to simply get warnings. But the VPC domain will come up, no problems with that. Okay, for a simple thing like, for example, VLANs are mismatched. Like you configured one VLANs in one side, the other VLANs on another side. Maybe there is no there's no consistency there. So in that case, you will see a global inconsistency. What happens is, for example, you allowed a VLAN 10 and 11 here, but only 10 is allowed here. So what happens for the VLAN 11, your communication will not happen. So if there is any server on this side expecting to be in VLAN 11, that will not work. But the others will continue to work. Domain will not have any effect. Okay, so you can see that like a warning. Oh, yeah, there is a VLAN mismatch. You can see that in the output. If you have an interface type 2 inconsistency, okay, it is going to, how do I put it? I don't know how to put it. I don't want to say warning. Only the relevant config is affected. I don't know how to put it in a better way. I'll give you an example, maybe you can understand it. For example, if I say this is a trunk port, so this side also I configured as a trunk port. So this is the VPC. So this is one VPC I configured. So here I configured trunk, here I configured trunk. But the thing is, here I allowed VLANs 10 and 11, but here I allowed only VLAN 10. So it's not going to create a problem. VPC will be up. But again, the VLAN 11, it will not talk. So that is a problem. It's not going to communicate. But it's not affecting my domain, my VPC itself. If there are any systems here with VLAN 10, they can still continue to communicate. Only the systems in VLAN 11, they can't go on this side. Okay, so that is the effect of it. End of the day, by looking at this table, you can very easily see which of them are mismatching, and basically you go to the other switch where you have a problem in consistency, and there you change the settings there. If the configurations are all same, then basically your VPC is up. The VPC domain is up, and VPC domain is up, and the VPCs are up. The VPCs comes up. So that is what happens as a step-by-step process. Important to know, when you talk about the failures, you will get to know the significance of each of these. So this is what happens as a step-by-step. From a configuration perspective, you simply configure the key flag, you simply configure the peer link, and then you start configuring the VPCs. Okay. Now, let us talk about the data patterns. See, STP is not running on the VPC links. It is still there. I'm not disabling STP by any means. But the thing is, it's not running on the VPC links. So let us say there is this server 1. Now you have your peer link, which happens to be a port channel. Must be a port channel, right? So let us talk about few things. 20. Let us 1/2, 1/2. Let us say 1/3, 1/3. Again, the number doesn't have to be same, but almost all the time you will have the same numbers. Maybe 1/10 here, maybe 1/20 here, which is like orphan ports, let us say. And then maybe you have your regular switched network. So your regular normal switches to which you are connecting again on a VPC basis you are connecting, or it could be an orphan port. But my point is right now I have maybe another server 4 here. So I'm just trying to understand. So there's the server 3, call it. See, if the frame is coming on this, from the server, the frame is coming. Okay, according to the server, this is a port channel. Again, this could be a server, this could be a switch, doesn't matter to me. Maybe there's a switch 3 here. Doesn't matter. When the frame comes from the system, again, it's a regular port channel. For the switch, it's a regular port channel. So it doesn't matter whether it is coming from a server directly or through the switch it is coming. Because it's a port channel, it will pick one of the ports. It does load balancing, right? So let us say the packet is going in this direction. Based on the hash, it has come here. Now when it comes here, oh, 1 second. Let me give some numbers to this. /20, /21. Yeah. So if the frame is coming in this side, what should I do now? Remember, I don't know where server 2 is, or maybe let us keep it even better, 1A, 2A, 3A, the MAC addresses. When it comes here, I will learn the source MAC address and the corresponding port number. Remember, end of the day, this is a switch. So I will learn, okay, 2A is connected to port channel 3. Because this is a port channel, right? This is a port channel, and this is another port channel. This is a port channel, and this is another port channel. So I learned this 2A, port channel 3, I got it. I don't know where the destination is. So if I don't know where the destination is, I will flood. So I will send it on this port, I will send it on this port, I will send it on this port, I will send it on this port. I don't know where the destination is. This is one of the things people think, oh, peer link, it is not used for the data path. No. Whenever you read any documentation, it says try to avoid using the peer link for data path. That's what we say. But there's absolutely nothing stopping us from sending the data on the peer link. As a matter of fact, a lot of times, as you will see right now, that the peer link will be used in the data path. No problems. So in this case, the frame is coming from server 2. I learned the source MAC and the corresponding port number, and I don't know where the destination is. So I will send it to all the active ports except the port through which I received. So when the switch 1 receives it, switch 1 also doesn't know where the destination is. So if it also sends it on all ports, then I have created a loop. Link went into this. So no, It doesn't work like that. It should not work like that. So port channel, STP is not running. STP is not running. So no active standby kind of a logic. So how do you avoid the loops? It does that not from a control plane, but it does that from a data plane. Let me tell you really what happens, and let me tell you how the data plane is used to avoid the loops. See, the frame has come from server 2, right? When the frame has come from server 2, it is coming on a VPC member port, which is a VPC. So when I learn this, okay, learn 2A is connected to port channel 3, immediately I will update this database to my peer. That is the purpose of the peer link. Remember, I told you peer link is used to synchronize the databases. It is used to synchronize the databases. Now you are trying to get that catch. As soon as I get the update about it, I learned this new MAC address from my VPC member port. I immediately tell this, synchronize this database to the other switch, other VPC peer. Okay. So now this switch also knows, okay, 2A is connected to port channel 3. Remember, the same VPC is configured on both the sides. Now this is what happens. This is the loop avoidance logic. When a frame comes from the VPC member port and goes through the peer link, when a frame comes from the VPC member port and goes through the peer link, that frame is not forwarded to any other VPC member ports. That is the loop avoidance logic. I'll repeat it. A frame coming from a VPC member port crossing the peer link will not be sent to any other member ports. So which means what happens here is, if the frame is coming in this direction, then the switch 1 is not going to send on any member ports. Now, if there is any orphan port, absolutely, I will send it. No problems at all. But to the member ports, I will not send. The logic is this: because it's a member port and the frame is received by switch 2, switch 2 would have already sent it, right? It would have already sent it through the member port to the server 1 or any other server downstream. It would send it. So I won't send it. That is the simple loop avoidance logic it applies. No control plane, no STP, nothing. Using this data plane logic, it will do it. Okay, good. The frame is coming from a member port and then going on the peer link. This switch will not send it to the member ports. Okay, but this switch 2 is sending on this side, and this switch will also send it on this side. Nah? So how do you stop it? 2 frames are going to the LAN. Okay. 2 conditions. First condition. Is this configured in the VPC fashion? Like this is a VPC member connecting to the third switch here. Is it VPC? If you say it is VPC, then a frame coming from the VPC member port going through the peer link, I won't send it on the VPC member port. So this is also a VPC member port, na? So I won't send it here. So that's not a discussion. But if you say, no, this is not a VPC, this is a regular LAN connection. If you say this is a regular LAN connection, then STP is already running on this. A loop is already detected. And through STP, rapid STP or MSTP, doesn't matter, I would have already put one port in blocking. It doesn't matter. It can be this port or it can be this port. Doesn't matter. One port in blocking. The other ports are in forwarding, like the root port, designated port, and all that. It would be my regular STP. Steve, STP is still running on this. So if the switch sent it on this side and it came to the peer link and this switch also sent it on this side, only one of them will be accepted because of the basic STP process. So duplicate frames will not go to your LAN, the traditional LAN. Okay? So the problem is solved. Got it? Okay. What if, so basically anything coming from the downstream, maybe server 2 is sending the frame on this side, it will learn the MAC address, 3A, maybe this one, right? Maybe 1A. Yeah, frame is coming on this side this time. 1A, learn it via port channel 2. I immediately synchronize with this MAC address table. So switch 2 will also know 1A is connected to port channel 2. Anything southbound, when they try to communicate to the other side, you are not duplicating it. You are not sending it back to it. So that is clear. Now, what if somebody initiates a communication from the northbound? So somebody in the traditional network, if they are trying to access the servers, what would happen then? Again, when the frame is coming on this side, this switch, again based on the STP, basic RSTP, one of them is blocked, and so you are not duplicating the frames. You are not duplicating the frames. Okay, so when you're not duplicating the frames, and if you are receiving the frame on this side, if the switch knows where the destinations are, it is simply going to send it on those member ports, respective member ports. If the destination is not known, then I am going to simply flood it to everybody, including sending it to switch 2. Now, when I receive it on switch 2, here is the tricky part, which certain documentations, not certain, most documentations don't show. If you are receiving it through this, am I supposed to send it to the VPC member ports or only to the orphan ports? Answer this, please. Guys.
Only the orphan.
Very good. Only to the orphan ports. Okay, and that is exactly what I do. Now, a lot of documentations, almost everybody everywhere will say this. A frame coming from the VPC member port going on the peer link, that will not be sent to other member ports. Yes, everybody says that. But what is missing is, even if I am receiving from a non-VPC member port, right? And if I'm sending it on my peer link, even that, I will not send it to the VPC member ports. I will only send it to the orphan ports. So fundamentally, if I am receiving the data frames from the peer link, I am simply going to send it only to those orphan ports. That is what really happens. Okay, so just like that, no STP, no nothing, and my data loop is avoided just by looking at the data frame, data path. Okay, any questions here, please?
Then can both links can be used simultaneously?
Yes. Answer this question. This is my next line, actually. This is the next thing I wanted to say. You give me the answer because I wanted to ask that question. You asked me 1 second before it. Answer, please. Anybody?
It's only for him or anyone can answer?
Anyone. I mean, yeah. Deepak asked the question which I wanted to ask. So Deepak does not know the answer. Others, yes.
Yeah, it will do a load balancing.
Yes. So if you observe very closely, it's not a very big observation also. Very easily you can observe. Some frames will be coming here, some frames will be coming here. If the frame comes to switch 2, I will synchronize with switch 1. If the frame comes to switch 1, I will synchronize with switch 2. If any IGMP request, join messages are coming, the switch 2 will learn about it. Immediately it will synchronize with switch 1. If this VPC domain happens to be the gateway, like I can run HSRP and all, if that happens to be the gateway, then my request will come and I will make an ARP entry of these servers. Then I will synchronize that database with switch 1, switch 2. So if you observe it from a data plane perspective, both of them are active. I mean, that's the whole point of a port channel, right? I need to have all the parallel links. I need more bandwidth. So from a data plane, they are active. Management plane, I told it a few times. Each one separately I will have to manage. So that is also active. And control plane, that is also active. So in all regards, they are parallelly working. In all regards, they are active. Now, in spite of all being active in all the planes, your VPC domain will have one selected as a primary and the other is selected as secondary. So once the VPC domain process is done, so VPC peer checks the availability of each of them through the keep alive, the peer link check is done. And now what happens is they will take the roles of primary and secondary. So before I introduced this concept of primary secondary, I wanted to complete discussing the data flow so that you already know it at this point. There is no primary secondary for data traffic. Okay, there's nothing like that. I mean, if there is something like that, then the VPC concept, the port channel concept is gone, totally out of the door. So data plane both are active, management plane both are active, control plane both are active. Then why do I need these primary secondary roles? What is the purpose of it? They are used in a couple of places. A couple of places we use it. In the failure scenarios, we use this. And when they interact with the regular STP, they use this primary secondary roles. And I will explain both of them. The one with lower priority becomes the primary, and the one, if the priorities are the same, and the one with the lower MAC address becomes the primary. Okay, so that's the criteria for primary and secondary. So what is the purpose of primary secondary? And that is in the failure scenarios, first thing. So let me talk about the possible failure scenarios. Okay, so the first failure scenario, what if something goes wrong with the VPC member port? What happens if the VPC member port goes down? Nothing. Really nothing, because at this point 2A is on port channel 3. This information is known to switch 2. It also is known to switch 1. As far as the server is concerned, half the bandwidth is gone, fine, but I still have another link which I can use. So half the bandwidth is gone, but communication wise, no problem. I'll just send the data on this side. Absolutely no problems with that. So there's nothing like a reconvergence. It's just like in a port channel, your link is gone, the remaining links you're going to use. So this is what happens when VPC member port goes down. There is no convergence. There's no convergence. Okay, don't get me wrong when I say no convergence event. Here the LACP will do the hashing for the next and the remaining links, and the load balancing will happen accordingly. All that will happen. Some of the bandwidth you lost, all of that. But from a VPC domain perspective, nothing. Okay, next. What happens when a VPC keep alive goes down? Keep alive is down, and peer link is up. So what happens if something goes wrong on the logical connection? Like they both are pinging into each other, right? Keep alives are sent back and forth. So what happens if that goes down? What happens to that if that layer 3 connection is gone? This is where I feel a little sad about keep alive. I told you, right? I feel a little sorry for it. Nothing happens. No reconvergence. Nothing. Really? Yeah, really. So this is the funny part. If I look at it, in the initial VPC bring up, if the keep alive is not there, that means if I cannot detect the 1.2, if I don't get the responses from 1.2, similarly 1.2, if it doesn't get responses from 1.1, the VPC domain will not even start. First, the keep alive should be there. If the keep alive is not there, even the peer link is there, I don't come up. First, my keep alive should come. So it's such important thing in the initial bring up, right? But once the VPC domain comes up, and then if the keep alive goes down, no problem. No problem. Because that is only as a backup. Only for backup I'm checking it. Okay. So nothing really changes.
But if peer link went down, then?
No, don't. I mean, there are 5 scenarios I will talk. Then you ask me if there is any other scenario you want to ask. Okay. Now, what if when VPC peer link goes down, what if the peer link goes down and keep alive link is up? What if the peer link goes down and the keep alive link is up? This is what happens. When the peer link goes down, as soon as the peer link goes down, the switches will check whether the neighbor, the peer is available or not. So they will ping and check whether the keep alive, whether the neighbor is there or not through the keep alive. Now the keep alive is up, I said. So when the keep alive is up, this is what happens. The secondary switch will bring all its member ports down. It will bring all of its member ports down. If any SVIs, that means if you are acting like a gateway, they will be down. So basically what I am saying is, see, the peer link is down. That means database synchronizations cannot happen, which means there can be some loops occurring. Therefore, secondary, I will shut down all my ports. Oh, all my ports. Not orphan ports, only member ports. For orphan ports, I'm still available. This is the reason why you need primary, secondary. When everything is up and active, there's no role of a primary, secondary. All are active. Both of them are actively going and doing things properly. But when the failure occurs, that is where the secondary comes into picture. So what happens is the peer link goes down. I will check whether the keep alive is there or not, checking the neighbor, and the keep alive is up. So the secondary switch will bring all of its member ports down. So now what happens to everybody here connected? Only half of the bandwidth is available. When the peer link comes up again, they will synchronize the databases and then the member ports will be brought up. Okay? Okay. Now the third scenario, like fourth scenario. What if when VPC keep alive goes down and then peer link goes down? What happens in this case? Crazy scenarios, huh? So it means keep alive went down, it seems. So they were pinging. Suddenly something went wrong in the network, gone. Keep alive is gone. And soon after that, peer link went down. What happens? Here is the problem. Here is the series of events that happen. The moment the keep alive goes down, what happens? We know that, right? Nothing happens. Okay, keep alive went down, no big deal. I'm still reaching the peer through my peer link, so no problem, I'm thinking. Just before I am thinking like this, peer link went down. So if this happens, if the peer VPC keep alive goes down and then the peer link goes down, both the switches will take the primary role, leading to split brain scenario. Meaning, the moment this is gone, the moment the peer link is gone, okay, keep alive is not there. Keep alive is already not there, no? So what they will think is, oh, something went wrong with the primary. Secondary is thinking like that. Oh, peer link is gone, something is wrong with the primary. So what I will do is, keep alive is also not there. So I will take the role of primary. Now, primary is hopefully still up and active. It will continue to be a primary. So this is a case where you can expect to see split brain. Both will now start acting like primary. Now here people will ask questions, like a rush of questions. So synchronization will not happen. Yes, it won't happen. Then there is possibility that the loops can happen. Yes, they can happen. How do you stop it? You can't stop them. Some will communicate, some will not communicate, depending on where the failure occurred. Maybe there will be a loop, maybe there will not be a loop. No guarantees. What? Really? Yes, really. Really, no guarantees. Anybody thinking I'm joking? Anybody thinking that there is something else? Don't think. I am not joking. There is nothing else. If the failure occurs in this particular order. Keep alive goes down, so both think they are okay. Then the peer link goes down. Then both will start acting like active routers or primary routers. Okay, that's a bad thing, but that's possible. Then another scenario. What happens if when VPC peer link goes down and then keep alive goes down? What happens when the peer link goes down and then the keep alive goes down? What happens then? Okay, let us check. So first thing is peer link went down, it seems. So the moment peer link goes down, S2 is checking whether the keep alive is there or not, right? And it saw that the keep alive is there, at least that 1 second time. So what secondary will do? Secondary brings its links down, right? Its VPC member ports and SVIs down. It will bring it down. And then the keep alive goes off. Okay? And then the keep alive goes off. What will secondary do? Nothing. Nothing else happens. By default, I would say. Is it a good thing or a bad thing? I don't know. It is almost like a peer link going down, right? Whether the keep alive is there or not, my reaction is the same. Secondary just brings its links down. Okay, those are the possible failure scenarios you can see. But let us try to explore this a little bit more, especially these things, right? This condition. Why is such a dramatic thing happening? Like peer link went down and then the keep alive went down. See, here is the chances, right? There is no guarantee, but here are the chances. If the peer link went down, definitely they are directly connected. So something went wrong with the cable or the port. That is one thing. If the keep alive went down, there are two possibilities. One, something went wrong in the network. Because of that, you are not able to ping to each other. So it's a network issue. Or your primary itself is gone, like shut down or hang, whatever happened. See, if there was an issue with the network, if there is an issue at the network level, for my VPCs, no problem. Why? Because they just have half of the bandwidth. Primary is good. I will send the data here. To whomever I can communicate, I will be able to communicate. Through this network, hopefully it will come to the switch. Hopefully, because I don't know, right, what happened in the switcher environment. So if it is having alternate paths, it will come and they go to the orphan ports. But these ports I have shut down here. That's fine, because the switch will send it to these member ports. So the other servers connected to other VPCs, they will receive it. So I have no problem when there is a network issue. Okay. But what if the primary switch itself went down? Network did not have any problem. The primary switch went down. So now what happened? Because the peer link is gone, secondary put all of its interfaces down. The keep alive is gone because the switch itself is down. So what happens to these servers? Because the switch is gone, these ports are gone. Because peer link is gone, switch 2 kept them in a disabled state. So these servers lost both. Okay. So this is a problem. Okay. So Cisco came up with a kind of a solution. Okay. I don't know whether you want to call it as an advantage or a disadvantage, but I'll tell you. Okay. They have a restore mechanism. Okay, there's a command to give this thing. If you enable the restore, okay, if you configure restore on the VPC domain, this is what happens. Okay. We call that as auto recovery. Auto recovery. If you enable this auto recovery, what happens is this. Peer link went down, right? Peer link went down. When the peer link went down, I make myself unavailable. So secondary will put all the member ports down. Then keep alive went down, right? With auto recovery enabled, what happens is this. The secondary will bring the VPC ports down. First of all, that will happen. Why? Because the peer link went down. Next, with auto recovery enabled, the secondary will check for keep alive 3 consecutive times. Check keep alive for 3 consecutive times. If no response, then takes the role of primary. It will take the role of primary. So if you enable auto recovery, this is what happens under this failure, under this sequence of failure. Is it a good thing? See this. Going back to the scenario I told you, peer link went down. So I brought my interfaces down, my members. Then keep alive went down. I am assuming because the primary is down, like the switch itself is down, right? That's the problem I was telling you before. Because the primary switch is down, the keep alive is not coming. So what secondary will do is, secondary will continuously check, right? It is continuously checking the keep alive. And 3 times I did not getting the response. Because I did not get the response, I will make myself the primary. Once I make myself the primary, now at least the servers will get half of the bandwidth. So with auto recovery, I am able to recover from this kind of a failure. But wait a minute, before you think it is all good, let me tell you, peer link went down. Okay? Keep alive went down after that. But the problem is not with the primary. Primary is still there. The problem is in the network. Something happened in the network, that's why the keep alive is not coming. So now what happens with auto recovery? Because keep alive is not coming for 3 consecutive times, I will make myself the primary. This is already working and primary. So now again you get a split gray. So do you want auto recovery or not? In production environment, they will enable it, by the way, but I don't know. Okay. So this is one scenario, the auto recovery will kick in. This is one scenario where auto recovery will kick in. There is another scenario where auto recovery will kick in. And that is, let us say both the switches are, just brought up. Okay, you just powered on both the systems. You have your keep pure link, and then you have your keep alive. So switch 1 you powered on, switch 2 you powered on. Both of them you powered on. Unfortunately, I don't know what happened. Switch 1 is not booting. I don't know, power failure, fluctuation, switch iOS crash, whatever, I don't know. It is not coming up. Switch 2 came up. What is the very first thing I need? What is the very first thing I need in the initial boot up? Keep alive should come up, na? But the switch is hanged. It's just not coming up. If auto recovery is not enabled, what happens? If the keep alive is not coming, I won't come up. I won't come up. VPC domain will not come up. So this is the second scenario where I can use auto recovery. So the default auto recovery timer is 240 seconds, which means I wait for 240 seconds for the keep alive to come. If the keep alive is not coming, then I will skip this step, basically. I will skip this step. I will skip this. I will skip this because there's no peer link. And I will skip this because there's no check. I cannot do the check. I will directly bring my member ports up. Okay, which means at least servers will get half of the band. Okay. This is another reason. So 2 reasons for auto recovery. When peer link goes down and the keep alive goes down, with auto recovery, I will check for 3 consecutive times. And if keep alive is not working, I will make myself the primary. It is good if the primary is itself having a problem. It is bad if the network had an issue with the keep alive. The second thing is in the initial boot up. When the primary doesn't come at all and only one device comes up, I need to wait for the keep alive. But if the keep alive is not coming for 240 seconds, when you enable auto recovery, it will take the role of primary. Is this good? At least this one is good. I don't know. I don't know. What if this is up? What if this is also up? The only problem is the keep alive, the network, by the time these two came up, by the time these 2 switches are up, network is having some issue. That's why the keep alive is not coming up for the next 10 minutes or so. So if you now enable auto recovery, which is enabled, I said, both will now again start becoming primary. How many of you are saying, oh my God? This is the thing. VPC definitely is used in environments. No doubts about that. As long as it is working good, everything is nice with VPC. When something goes wrong in a particular sequence, even Cisco can't help.
Okay, Kalyan. This auto recovery, is it something works similar to preemption?
I don't know how you want to look at it. Yeah, loosely you can think of it like that. Loosely. Yeah. And by the way, because you raised it that point, VPC preemption is not enabled. No preemption is there. Okay. Which means you have this simple failure, right? A simple failure occurred, for example, like peer link went down. Okay. Or let us take a even simpler one. Okay. So your switches, switch 1, switch 2, this is active, I mean this is primary and this is secondary. This is restarted, okay? Because you restarted the peer link, keep alive is gone, auto recovery is enabled, so this becomes primary. Okay. Now when this comes up again, will this be the primary? No, it won't be the primary. The priority is less still. Because the primary is already set, it will now be operational secondary, we call it. So if you look at the outputs, you will see that status is primary, but operational status is secondary. So preemption is not enabled actually. You can't even enable it. Okay. But I understand why you said that. Okay. Okay. It's not waiting for the primary. It is automatically becoming the primary. So can I say preemption is, yeah, loosely you can say that. Technically, no, but end result is the same. Yeah.
Yeah, got it. Yeah, thanks.
Okay.
So
yeah, please.
Is there any concept of tracking interface once primary interface come up, so it will take the role of primary back?
No. Okay. No, when I said your keep alive itself is a tracking interface, na? You're getting it?
Yes.
Your keep alive itself is a tracking interface. So there is, what else is again a tracking interface for the keep alive? Now I need to keep on recursing that. Okay. But said that when you have HSRP, when you run HSRP, for example, on this VPC domain, which is a point worth knowing, you can very well run HSRP on this VPC domain. When you run HSRP on this, you have your VIP address, you have your physical interface. In this case, SPI will have an IP address of 10.2, SPI will have an IP address of 10.3, the VIP address is 10.1. One of them is active, one of them is a standby, right? Here is the difference with HSRP with VPC domain. When you look at the outputs, you see them as active standby. However, when the data is coming for the gateway 10.1, both of them will actively send the data out. So maybe there's a routing adjacency on this tier. I don't know whether it's a layer 3 switch or a router. I don't care. But you are able to actively send. You don't send it to the active router. So with HSRP on VPC domain, you can actually get load balancing. It happens. You don't have to do anything special. It just happens. So when I am running HSRP, will I do the same trackings of these interfaces and, no, these are layer 3 interfaces, right? So can I track these interfaces, and if that is down, can I bring my interfaces down? Yeah, you can do all that stuff. Okay. So all of that you can do, but for the peer domain itself, VPC domain itself, there is nothing of that tracking and tracking and tracking. Okay. That is one thing worth knowing, right? Then the second thing I want to highlight here is with regards to STP, right? The regular STP that we have. So let us say this is switch 1, this is switch 2, and it is connected to your regular LAN. It is connected to the regular LAN. No VPC, nothing. It's just your whatever, cutlass switches, access switches, whatever you have. Okay. What happens is only the primary will send the BPDUs. If you configure STP on this, the primary will send the BPDUs. So the BPDUs, when they are sent, the BPDU will come on the peer link also this side. It will also come on this side. Like just any other switch, even though RSTP is running, S2 being a secondary, it will send the BPDUs of the primary. So for example, if this guy's bridge ID is, I don't know, just as an example, I will say 55A. If this guy's bridge ID is 55B, priority and the MAC address, okay? I configured this VPC domain as a single switch, right? So outward, when they look at it, when they look at this switch, they will see it as a single switch. They don't see it as two switches. Why? Because the secondary will not send its BPDUs. It won't. Whatever is the bridge ID of the primary, that is what I will propagate. So this guy will send the BPDUs this side and he will send. So when the switches look at it, they will look at the bridge ID as 55A coming on this side and coming on this side. So for the LAN, it looks like a single switch because that's how the switch is identified, right? Using the bridge ID. It will look like a single switch. This is what happens with, this is another difference between primary and secondary. So this is what happens with STP BPDU propagation. Okay, now let us say this is the best priority. 55 is the best priority. So everybody decided this switch, logically 1, physically 2. This switch as the root, right? So they will have their root port on this side. They will have a root port on this side. This will be the designated port. This will be the designated port. All is good. Now what happens if this goes down? If the switch 1 goes down, what happens? See, before the primary went down, the BPDUs are not originated by the secondary, right? So when the primary goes down, then because the secondary will become the primary, operational primary, it will start sending the BPDUs. Now when it starts sending the BPDU, it will send its bridge ID, 55B. Now, according to the priority, still this is the root port, still this is the designated port. No changes there. But even though the port has no changes, because the bridge ID is changed from 55A to 55B, for the local LAN, it's a reconvergence event. No, LAN will think, oh, there's another new switch connected to this port, and so we have to reconverge. We can save that little bit of reconvergence time. We can do that. We can do that by configuring what is called as peer switch. It's just a single command we give on both these VPC peers. When you configure peer switch, the behavior changes. The way the behavior changes is when both are up and active, like the primary is there, secondary is also there. The secondary will also send BPDUs. It's not going to simply propagate, but it will also send the BPDUs. Here is an interesting thing. It will send the BPDUs like 55A. So it got the information about its BPDU, its priority and the MAC address from switch 1. It will send it. It will originate like I am 55A. Just by enabling this command, now both the switches are originating the BPDU with the same bridge ID. With the same bridge ID, they will be originating. Now, because they're originating with the same bridge ID, tomorrow if something goes wrong here, the network does not know anything about it, does not reconverge. Because as far as the others are concerned, switch 2 secondary is still sending the same BPDUs. It's a very interesting output, first time when you see. When you look at STP, when you run, when you make them the root, When you look at this switch inside, when you say show spanning tree, you will see a very interesting output. The interesting output you will see is, I am the root. You will see that even in regular switches, right? This switch is the root. That's how you will see really. This switch is the root. And then one of the ports will be a root port, because this is the primary with the lesser priority and the MAC address. This is the root port, right? STP root port, and this is the designated port. The interesting thing is, in a normal STP process, a root switch will never have a root port. It will never have a root port. The root port is a port of a non-designated switch. But because of this behavior, two switches behaving or mocking like a single switch, if you go to this secondary, you will see that it is a root, but then you will have a root port pointing in the actual root switch direction. It's a very interesting output. But then, you know why we give the peer switch, okay? That is one thing which we kind of bluntly we configure. Okay. And there is a last thing that I want to mention. You have your SVI configured, for example, 10.2, which has a MAC address of 2A. Then there is an SVI 10.3, which has a MAC address of 3A. And then there is a VIP address and the MAC address. Now, by far, when somebody wants to talk to the gateway, they will always contact the virtual MAC address and the virtual IP address. That's what they will contact. Personally, I never saw nor heard of anything that uses the physical MAC address of the gateway. So this is the gateway, right? So physical MAC address of the gateway, I never saw a reason why somebody will use it. It did not make sense. It doesn't make sense to me, because whenever a server wants to talk to the gateway, it will send an R broadcast. We know that. The active router will send the virtual MAC address. In this case, VPC, both are going to be active, right? Even though it says active standby, both are active. So one of them will send 1A as the MAC address. So everybody will have 1A as the MAC address. But documentation says there may be some devices, especially some old storage devices. Personally, I don't know what they are. But there may be some devices which, when they want to talk to the gateway, instead of using the instead of using the virtual MAC address, they will use the physical MAC address of the gateway. Oh, so if this storage, the old storage box, if it wants to communicate to 10.1, it will use the physical MAC address, it seems. So if it is using physical MAC address, remember this is a regular port channel. If the frames to the gateway are going in this direction, no problem, right? Because 10.2, 2A is here, no problem. But if they're going in this direction because of load balancing algorithm, that data, if it came for 1A, I would have sent it. If it came for virtual MAC, I would have sent it. But it is coming for physical MAC, right? So I will send it on the port, peer link, and then I will have to send it. So unnecessary traffic flow on the peer link. For that, there is another command which people give, pretty much like a blindfolded thing. They configure what is called as peer gateway. When I configure peer gateway command, what happens is, not only for the virtual MAC, even for the physical MACs, they both will respond to each other's physical MAC. So in this example, if a frame comes to 3A, I will respond. If a frame comes to 2A, the physical MAC of my peer, I will respond. If a frame comes to 1A, that also I will respond. Same thing here. For 2A, I will respond, 3A, I will respond, 1A, I will respond. Okay. My opinion, this is something which we don't see in networks today. We don't see in networks today. At the same time, nothing hurts, right? By giving this command, no damage is going to happen. So give it. That's what people are doing. Just give it. Peer switch, enter. Peer gateway, enter. These are like, in the total VPC itself, there are like only 10 configs. That's all you can do. Configuration is very simple actually. So they'll just give it. Okay. So I think that's where I want to draw the line for VPCs.
Kalyan, can you explain about VPC plus something?
Okay. I will talk about it. Okay. VPC plus is a combination of what the hell am I drawing here? Don't worry. Tomorrow you will learn it. Is a combination of fabric path running on top of the network and VPC domain running below. So you have a VPC domain on southbound interfaces, and on the northbound interfaces you are using the technology fabric path. When you combine these two, they call it VPC plus. So for you right now, it is too early to discuss. Tomorrow, once I talk about fabric path, we will discuss that. There's nothing to discuss at that point. Okay, but we will introduce that. Okay?
Okay. Yeah, thanks.
Right. Yeah. All right, guys. So VPC is a very ugly protocol, really. They thought of doing something, but they did something, and finally, yeah. Again, don't get me wrong. Everybody is using VPCs in today's networks. Hope the failure which I explained is not going to happen in your network. That's it. Okay. If that happens, Cisco itself says disable VPC, like no VPC, no feature VPC, that's it. And then fall back to spanning tree. Just once you disable VPC, spanning tree is running. Half the links will be up, half the links will be down. No problem. Then you come and solve your physical problems. Why did the keep alive go down? Why did the peer link go down? Why is my primary not coming up? You solve those problems and then bring the VPC up. Okay. But hopefully, most likely, if the power supplies are redundant, if the cables are redundant, if the racks are redundant, hopefully you will not have such weird failures.
Kalyan,
Yeah.
if there are two switches within a VPC domain, and if I reboot means primary or secondary, and if I reboot the primary switch, so there shouldn't be any negative impact on the production because we have another secondary switch.
Absolutely no problem.
And what if connectivity gets a break? There is a lag. So what could be the reason? Like the scenario is there are two switches in a VPC and we have rebooted the primary one, but suddenly we lost the connectivity.
To whom?
When
Primary.
it comes up, yeah, primary. And when it comes up, everything
From the secondary. Yeah?
No, means
secondary.
we have rebooted the primary one. As soon as we rebooted, means we lost the
Secondary is
connectivity.
there, huh? Secondary is already running, huh?
Yeah, secondary is running. But we lost the connectivity for 5 minutes, means the times which switch takes to reload. And once it is reloaded, again we got the connectivity.
Okay. Expected.
So what could be the reason?
That's expected, right? 5 minutes of booting time is there, no?
Yeah. Means there shouldn't be any issue. We have secondary switch. So why we lost the connectivity?
When you say lost connectivity, you lost connectivity to the servers, is it?
Yes.
Oh, okay. No clue. Absolutely no clue. If I have to guess, you did not lose 5 minutes. Maybe you lost 240 seconds, 6 minutes, or 4 minutes, maybe. I don't know.
Yeah, that might be. But
auto recovery is enabled, right? Mostly, hopefully. If auto recovery is not enabled, if this is exactly what happens, like for example, primary is here, secondary is here, you just shut down this guy, which means the peer link is gone. At the same time, the keep alive is also gone.
Yes.
The moment they are all gone, this will now become operational
active
primary.
Yes.
Okay. When this becomes operational primary, immediately these guys should be able to go on this link.
Yes.
Okay. So what is the sequence of events happened when this went down? I don't know. And that's why it is very difficult to answer the question. Did the secondary detect the peer link gone first and then detected the keep alive gone? Or did it detect the keep alive gone first and then the peer link gone first? We don't know. It's a very, very ugly protocol. You're getting the point, right? From your perspective and my perspective, this is gone, this will take control. But now you know the reaction logic. You know the reaction logic on a sequence of events. Peer link goes down, then the keep alive is a different thing. Keep alive goes down and then the peer link goes down is a different thing. So,
but when one switch is completely down, then secondary switch should take over the role actually.
No. It took the role. So it is not like dummy. It took the role. But the challenge is, why did it take that much of a time is the challenge. So that is dictated by how it has detected them. For you and me, primary went down. But
yes.
Did the secondary detect the keep alive down first and then the peer link down? Did it detect the peer link down first or then the keep alive down? How would I know? How would anybody know about it, right? It's a matter of timing.
Okay.
So very, very, very
ugly protocol.
Yeah.
Actually, we were doing the Nexus firmware upgrade of the Nexus switches 9K. So we just rebooted the primary one, and what we were thinking that there is a secondary switch that will take over the role, but we lost the connectivity around 5-6 minutes.
Okay. That's what. As long as it is working, it's a good protocol. Once it stops working, disable it. Right. Really, Cisco says that. So, yeah.
Luckily, we were in the maintenance change window. So.
All right. Good. Okay, guys. So we will wind up for the day. Tomorrow we are meeting 10 o'clock. OTV.